hold on, sorry. Sorry about that, guys. Okay, back again. So we have put everything that was on the 14th is now available here in the 20th. This class is going to be for 3 to 4 hours. And if you're tired, we are going to take a 15-minute break. I'll try to work on your OpenVPN issues. We need all your VPNs to work this weekend. I'm not going to allow you to wait until next week to do the assignments. So we need the OpenVPN to work. We need you to be able to get into the machine. We want you to be able to access those machines. Okay. You cannot access the machine using Bilal_Khan. That was just an example. You have to use your own ID. And if your ID is not working, that's because the backend is not working, right? So the first slide is very simple and straightforward. Let me open for you. Let me just 1 second. Let me exit. Let me open okay, SSH root at 192.168.1 dot sorry 97. Okay. So you can, for now, you can practice this on Guacamole. That's why we start with, because OpenVPN does have problems sometimes, but we will fix them. So in the beginning of the class, we didn't do all of that, right? So one thing we are going to learn today is number one, we have talked about the history command already. Everybody knows about the history command. The other command that we are going to practice, and we are not going to practice that too much right now, but to show you, there's a very popular command called the find command. There are about 2 to 3 questions on the Red Hat exam about how to use the find command. Okay. So the find command is the way the find command works is, as you can see, the first thing you do in a find command is um, you're going to write the find command. Okay. That's the first thing. This is pound, or if you are a normal user, it doesn't matter. So you're running the find command. So that's the find over here, right? Find command. That's the first thing that you put in the line. Then you have to define the path. Okay, the path is, for example, you're trying to search in the entire directory. You can leave it that way, right? Then you have to look for what are you looking for. A lot of times we are only looking for a file or directory, right? So if you're looking for a file or directory, or you're looking for something specific, um, we look at the flags. So the type is minus type, right? You put the minus type, okay? Um, and if you want to use, here you have a choice. You can either go file F like this one, or you can do D for directory, right? Whichever one you want to choose, this or this, okay? So let's say we are looking for a file, okay? Then you have about 1, 2, 3, 4, 5, 6, which are specialized searches. There is a 7 also here that we're going to talk about. The special cases that the Red Hat exam will test you on this case. They want you to run this case. Of course, they'll always try to give you the most challenging one, but it's not challenging when you. So number one, you will type the find command. Number two, you are going to define the path, right? The path is there, right? So you have the command, right? You have the command, okay? You have the command, and you have the path, and then of course you have the file or directory, the type. Okay. Now you're going to add a flag. You're going to add one of these flag. If you're searching for user, right? If you're searching for a name, Joe, Joe is the person you're looking for. You're looking for Asim. You're looking for Ifra. You're looking for Asir. You're looking for Majid Adeyemi, Sahid, whoever the user is going to be in that Linux system. Remember the Linux system? You have the root directory, and then you have all these directories over here, right? You have all these directories over here. So you're doing a find, right? You're starting a find over here. So now from the top, from the very top. This is the very top. You can see here the path is the top. The path is, I'm saying find, meaning come over here. This is where I'm going to start my search, right? And I'm going to look all the way down into all the directories. I don't know if Joe is in home. I don't know if Joe has a file in some other system. I don't know. Maybe he's in the temp directory. Maybe there's a temp directory, and Joe is inside temp. He's not in the home. Maybe Joe has left the company. He left some files, and the files are part. His profile does not exist, but his files exist. So find command is going to look for anything that you tell. So what do I want to do here? What is it that where? This is where. Where do you want to look? Where do you want to look? कहाँ से तलाश करना है? Where do you find it? So I'm saying I want to find it in the from the root, starting from here. You can go from home. You can say, oh, I want to check in the var folder. Okay, I can check in the what do you call this, etc folder. You can do your search anywhere you want. But one of the safest searches is to do the search from the top of the tree. So now you say, okay, I want to type. Where do I want to go? I want to go here at the top. That I said / over here. What type? What am I looking for? I'm looking for a file. Remember, Linux is a file or directories. I'm looking for a file. Type is file. Who am I looking for? Right? What am I looking for? Now, in this case, who? In this case, I'm looking for Joe. And I'm looking for hyphen name Joe. And maybe the file name of Joe is, let's say, project. So this is the name of the file, right? Name of the file. So this is your one search number one. Okay. Now we have, if we are going to do the search here, you will see that you can look for file sizes. This is a very big problem in the company. A lot of times, which file has the largest size. So you can actually come to the minus. You can come to the minus type, right? Type file minus size. If you want to know who's the user, minus user. If you not know if you're looking for any empty files, minus empty. Okay. So let's look at, so basically then you'll just put the size. Is it plus 20 megabyte, or do I need to look for user John? If I'm looking for a user, it's user John. If it's an empty file, if it has a minimum number of days, how many days, how old is this file? So I'm just want to show you the method. This is the easy way and find command is on the Red Hat exam. There are about 2 or 3 questions from using the find command. And that is another 10% of the exam. So I'm showing you this. We will do a Red Hat mock exam where you're going to be able to, we're going to give you the questions and the answers this coming week. So now let's move on to our next thing, how to run some of these commands. As you can say, how to find all the files and directories connected to John, right? So here we can see the find command, how it is working. Okay, so we are running the find command, right? Then we have the path. Then path is home. Sorry, let me remove this. Very confusing. Let me use something like a white marker here. So you have the find command, then you have the path, you have the type. Okay, the type is F, which is the file, and then you're looking for John. You're looking for all the files related to John. Okay, so if you want to find the directory, D for John. How to find all the files that were modified in the last 20 minutes. So find all the files under the folder var, right? The type is files, and the minimum time is 20 minutes. Modified, those that have been modified, M, and the time was last 20 minutes, minus 20. Now, we will do some exercises next week on a lot of exercises on the find command. We will do like maybe 10 different types of versions of find command. So you'll become really good at it. Now, how to find all the files that are older than 1 day under the temp and remove them? Meaning, I want to look for in my system, I'm going to look for a file for files that are in the temp folder that are older than 1 day, because you have a policy in the company, right? That every day, your Linux system goes and looks at the temp folder, and most files cannot stay more than 2 days or 3 days. Some companies delete all the files. So so if there is a problem in the system and there's a ticket that if a particular file is causing problem in the temp and they couldn't delete it, they'll basically say, okay, find that file, okay, the type of that file, minimum time was 1 day, okay, and then you're going to run a command which looks like this. This is a syntax you have to memorize. You have to memorize it. Write it on a piece of paper, understand how the syntax works. We are going to change this syntax. So you're going to execute once you have, once the result is here, right? If you did not write this here, if you didn't write this here, if you don't have this here, you will have an output on your screen. Okay. What we are saying is take that output, whatever you're going to put output on the screen, rather than putting it out on the screen, take it here. Run this output through this command, execute this command on that output, meaning remove that file. If you found a file, let's say you found a file called HTML index.html. Okay, you find the file. Now this find is going to show you the find if you don't use this. But you're saying if you find the file, now go ahead and execute it. Execute this command on it. rm-rf, okay, and open curly bracket, close curly bracket, / semicolon. This you have to memorize. That's it. This is the syntax you have to memorize. It's like it is a way of executing and kind of closing the bracket. So this means open curly bracket, / colon. These are the three things you need to memorize. This is very easy. This is an operation. Okay, this is an operation. And there are multiple ways to do the operations. So you have done the find up to this point. Okay, easy. What else do you want to do with the output? What do I want to do with that output? Now you can decide that you want to do some operation on that output, right? Just like somebody gives you something in your hand, what do you want to do with it? I give you 2 tea bags of tea. I said, what do you want to do with it? You know, oh, I love this is I want to throw it in the garbage can. Somebody, you have a used box in your house. Somebody hands you a box, empty box. You say, well, what do you want me to do with this? Oh, please, can you throw it in the garbage can? So the find command is like finding a box, and the box is like giving it over to you. And you basically go and do an execution. You do an operation on that box. And you say, okay, let me remove this. Let me put it in the garbage can. But in order to do and complete the operation, this command needs three things. It needs it needs the curly brackets. It needs the curly brackets. It needs a / and it needs the same. How do you memorize this? Very easy. 1, 2, 3. Remember, there are three things that have to come at the end. You have to have three things coming in the end. Okay. So the three things that have to come in the end is your curly bracket, your / and your colon. So just in the 1 week, you should be able to memorize this. 1, 2, 3. One is curly bracket, 2 / 3. So when you're sitting on the Red Hat exam, this is where people usually are forgetting. You are able to use the find command. Very easy. You're done with this part. Now the Red Hat exam is saying, take the output and do something with it. They can ask you many things. There are two or three things they can ask you. One of the questions will always be execute a command and remove the file. Okay. Now the student is doing this in the exam, but he says, oh, what do I put here? I can't remember what is here. So remember, you have one, two, three things that have to go here. One, you're going to have your curly bracket. Two, you're going to have your forward slash. Three, you're going to have your semicolon. Now you hit enter. You have successfully passed the Red Hat exam question and got your 10% of the exam. You have 10%. You have proven yourself as a system administrator. You have proven to everybody you know how to find and you know how to do an extra operation on that find. So what the Red Hat exam is testing you is, can you find number one, can you find something in the system? Can you do that? So they're trying to prove that yes, I can do that. I can run a find command. Now the question number one is question number two. Can you do some operation on this find on the output? When you get an output, can you do some operation like delete it, remove it? Can you do that? Yes. How do you close out the operation? How do you close out this operation? You have to have the curly bracket, okay? You have to have a forward slash, and you have to have this. This is the syntax that people forget on the exam. Okay, this is where people forget. People don't forget how to do this. This is very easy, very easy, very easy. Good, good. If you do all the examples in the class, you can close your eyes and use the find command. Very easy. Whatever I give you, you'll be able to do it. Okay. But the part that is complicated or seems complicated is, what if we have to now put an operation on this? Okay, we want to operate on this, do something more with the output, and how do we close the output? Okay, this is where most people fail. They fail either here or they fail over here. So that's why the Red Hat exam tests you on these two features. This part, very easy. They know that anybody can learn this. It is this part that they test you on. Okay, good. We are going to continue. Right. We have a lot of material today. So I've given you some small thing. Now, Asim mentioned that for those of you who are coming after a long time, you can see that in these images, sometimes the distance is not clear, right? Remember that anytime you type a command, there has to be a space. There has to be a space. There is a space. There is a space. You can't just put type F. It's going to fail, right? So remember that you're writing these, when you see a little gap, there's a space. Sometimes it is hard to show that, but when we do when we load the day one, the task for day 45, 46, 47, it will be very clear in there. We'll give those commands very clearly. In the slides, it is not clear. Okay. So look at this one. It says, find a type file greater than 20 megabyte. And what do? You execute. You do a listing, ls-ld. This is the execution. See, very easy. What did the Red Hat exam over here ask? They did not say do RM. They did not say do RM-RF. No, sir. No, ma'am. They asked you to do ls-ld. Do a listing. That's what they want you to do. That's what you do. This is the key part. How do you close the operation? So here is the operation, and here is the closing of the operation. This is the syntax for finding. So very simple. This is how you need to understand and learn the command. Don't get so confused with such a long string that people look at this first time and they say, oh my God, how will I work this? So we will give you enough problems to ace the exam. We'll give you the actual exam questions that come out, which will make it easy similar to the exam questions that come out. I won't say actual exam questions, but similarly to the exam questions, right? Okay. Now that's the find command. We do have the stat command. I'm not going to talk much about it. We are going to use it a lot. In yellow, you can see that we are looking at the statistics of a file. You can run this on a directory as well. So we have The stat command space. Remember, there is a space over here. And then this is the name of the file. Okay, this is the file name. And it's going to tell you the name of the file. It's going to tell you uh, the permissions, because that's what we are going to learn today. We're going to learn about permissions. And then we are also going to learn next week about SE Linux. And then we're going to pick up on this final part next week. Okay. And we're going to cover SE Linux, and we're going to cover this context, and we're going to go through that. Right. So if today you guys understand what I'm teaching, you guys will be able to clear 25%. You have mastered, you have mastered 25% of Linux today. These slides, I have redesigned them. I guarantee you, you are 25% on top of the world. 25%. You are 25% on top of probably almost 7 billion people on the planet. Okay. So 25% is a lot. So that's what we call mastering Linux. Now, 6 weeks have gone by. We have this class today. We just have to understand. So we have done the find command, right? We do the stat command. Anytime we talk about commands, we're talking about what? We're talking about file operations. File operations. These are or we are operating on files. We're running a command. It gives us an output. PWD, okay, is a file operation, right? Or you're doing some kind of command you're running. But file operation is specifically on the file, right? Find command is a file operating command. It's working on the file. You're doing something with the file. PWD is just a command. It's not working on a file, though PWD, everything in Linux is a file. But the story is very straightforward and simple, right? So let's clear that. Let's keep on going. So now let's enter this command we talked about. Standard in, standard out. If you're typing on the keyboard, that's a standard in. And if you get an output on your screen, then that's a standard out. We talked about this last time. To type PWD, you're going to get maybe the home of Tom or something like that, if that's where you are located. Okay. Now, there is one mistake in this slide, and let me see if you see. I'm doing PWD, and this should just be showing me right over here, just root. Okay. The output should be straightforward. Okay. This is not the output. The output is this. Okay. Okay. Let's delete that. Let's do this right. Let's do it the right way. That's the output. That's the output you should see. And I will load this file again with version 3. So if you are typing PWD, you're going to get an answer like that root, right? Because your root is checking in their home. Tilde stands for home. Okay. We are going to learn about this tilde. Oh, you guys are thinking, we are just talking about tilde, and you should know. I have a slide where I'm going to talk about what is tilde. What is tilde? Tilde equals to what? Tilde equals to for root, it is slash and root. Okay, that's for tilde. For a common user, tilde is slash home slash user. When you have somebody with a dollar sign, right? They are with a dollar sign. The tilde means this. This whole expression is tilde for a normal user. For the root user, it means this. That's what tilde means. Tilde is equal to this for the root. Tilde is equal to this, home and user. Very important to understand what tilde is. Tilde is this and this. It is not just the user. Okay, we are going to talk about it again. I'm warming you up. We're going to use this because when you are going to master Linux and somebody asks you what is tilde, and you are taking a Red Hat certified guy, you cannot be saying, oh, tilde means home. Tilde means tinde. No, tilde means this. No, you should know what tilde means in your language. You're using it now for the last 2 weeks, 3 weeks. You should have been noticing the tilde now. I've been talking about it. Now I don't have to start and say, what is tilde, right? Tilde is there. Tilde is the home of the root, and tilde is the home of the user. Now, we are going to learn more about this. So for now, don't worry. If you have got the concept and not yet, we're going to find more information. So I type PWD, right, is the input. So if I type in PWSD, right, that means the command is not found. That means it's an error. We did talk about this. Whenever you type something in, either you're going to get a standard out. Standard out means it is printed to your terminal. Standard error is also printed to your terminal, right? You have a terminal in front of you. It is printing command not found, permission denied. These are all errors that you're going to get, that you see on your screen. You will see good and bad both on your screen. But the reason we are learning this part is because you have a number of things to keep in mind. We studied last week. If you want to redirect, you have the angle bracket. This is called an angle bracket, right? You have, let me do this. Okay. So you have angle bracket. It means you are doing the override. Okay. If you are doing the double angle bracket, that means you're doing the append. For those who did not attend last week's class, that is fine. We are not going to run the things, but I'll show you. This one takes an input. Okay. This one redirects an error. Okay. This is two, because why? One is standard in. Standard input is one. Standard input in Linux is equal to one. Standard output out is a two. And standard error, sorry, this is zero. This is one. And the standard error is equal to two. So where you see a two, it's a redirecting an error, meaning you are going to run a command, right? You run a command where you want to create a file, touch project, and you get an error. Touch project, you get an error. Error says permission denied. So that permission denied, if you do not want to see this error, you can again this output, right? This is the output. Let me show you. Let me help you understand what are we trying to do from all of this commands. A lot of people after the class, they ask the question, what are we trying to do? We are trying to use some commands, be very clear. We are trying to master the Red Hat exam. We said that the Red Hat exam requires you to have a good understanding of the find command. So now, if you are asking the question, what am I teaching? And you're still confused, please, during the question and answer, open the mic and don't be shy. Say, I am confused. I don't understand what we are learning. Okay, because it is very important to understand what are we learning? What are we trying to achieve in this next 3 hours? Okay, what is it that you're going to gain from all of this? Why are we putting all of this information in front of you? So this is not just okay, okay, okay. Remember that every slide that I have put, you do not need to go to the internet to find anything. Every slide has a meaning. You cannot go wrong. This is all reference material for you. Okay. Any other search you do on the online, it's just going to help you learn more. Okay. We said that if you run a find command, okay, you run a find command on something, and what do you get? Okay. You run a find command on this file, you say minus type file, type, right? Space file, and you are trying to find a file called project, for example. Now, there is no file in the system called project. So there is going to be an output. This will give you an output. It will say error. Okay. Now, if that error is going to be printed on your screen, you will see the error. If you hit enter, line one, you will command line two, it will give you the output. The output is going to be what? You have an error. Why is there an error? Error is there because this file does not exist. So Linux is saying, I cannot find it, or there's a problem. I got a problem. So this is called an output. This output are of two types. If it is a good output, if the output is what you like, it is equal to 1. If the output is bad, like an F, it is equal to 2. Are we clear? Are we clear, guys? बात समझ में आ रही है? बताएं, वो माइक खोल के बताएं जरा.
यस। जी जी, समझ आ गई।
Yes, sir.
यस।
Yes, yes,
Okay, Abdul Rahman, you are clear, right, Abhi?
yes, yes, sir.
Wonderful, wonderful. So remember, in Linux, it is very easy. You type something, either you like it or you don't like it. So when you don't like it, sometimes you want to manage the don't like part. So then you get a 2. Then you see this over here, 2, 2. So if I see an error, what do? I want to redirect. Where do I get this one from? Over here. So we have the 2 and we have the redirect. So we are using this, and if you combine them together, then you have this. Okay? Redirects only errors. All right? Now, there is an old way. I've used that example in this class, the old way of Linux. And now you have a new way where they're saying you don't have to put the 2, you don't have to do anything. You can actually use this command, but we're going to talk about it. Then last week, somebody had asked us a question that if I type in echo, okay, I type echo, it says system log, okay, and I have an option. I can go direct, redirect it, or I can append it. And this output echo system log, right? This is the command. This is the output. Okay. If I don't use any of this, what happens? It'll just print it to the screen. Let me show you. Okay, let me show you. Understand this. Very easy. Very easy to understand this material, my ladies and gentlemen. All right. You can never forget this after today. Trust me. Let me try to get out of here. Okay. Now, if I open this in front of you, all right. So if I did echo system log, what happened? I got the command printed out here on the screen, right? But if I want this echo, let's see how many files we have in the system. Okay, we have a bunch of RM hyphen RF. Okay, we have output file. Okay, we have output file. Let me get output. Last week we were using this file. So we have a file with an output. So let me just delete the material inside output. Okay, so let's clear this. So if I said echo output, now remember guys, I can type in the history command and it'll give me all the history of everything I've been typing. So I can see the history is how long is this history, right? You can I have exceeded 999, 1000. I have like 10, I have modified the history size for my file to about 10,000. So I can keep on going, right? I have all these history up here that is saved. Everything that I've used is here. So now the last history was echo output here. So we have echo here, 1001. So we can do the exclamation 1001. What is that going to do? It is going to execute that command. Okay. So now I can just put in echo system log, echo system log, output to the screen, echo system log. Let us redirect it to the output.txt. Okay, that has gone, where did it go? Right? So we are redirecting it. Okay, we are redirecting it to a file, meaning we are doing an operation on the output. We took the output We are saying take that output and redirect it, put it inside the output file. So cat output dot txt. I'll show you the system log is there. Now we can do echo rsys log, and we say output.txt. Now we cat again the output.txt. We see that the original file of system log has been overwritten by rsys log. If I want to append, all I have to do is I can just put in there the append. This is to append. Okay, enter. If I now cat, okay, I can see that I've appended that. Now there's one more command we didn't do that I want to show you. Right here, we have this command. Okay, so let us delete clear all. Right, there is this command over here. Okay, this command. This command has a syntax called cat, and it's going to open up a file for you. All right. So let's look at this. Let's look at this command. Now, let me stop this. Let us go what we have been doing. Let's first of all clear this um, screen. So we are moving forward. So we are basically saying this means override, this means append. Okay. Let us create a practice directory, which we can, and we can practice what I just practiced already for redirect. So we are redirecting, but we are overwriting. Then we are saying we are redirecting and we are appending. We did this last week as well. And then we are. I'm not going to do this exercise. You can do it. We did this last week. But the one that I wanted to talk about was this one that we didn't do. Okay, so this is the syntax of it, right? So what is the syntax? Um, this particular one is very interesting, right? If you look at this example I've put for you, we clear that. If you run the cat command and you do EOF, EOF means end of file. Okay. So what is the file? The file is going to be output.txt. Okay. And then I hit enter. Now it is telling me, give me whatever you want to give me. Okay. So I'm going to put in there um, hash. Sorry, where is the hash? Hash. Okay. And bin bash. This is the first thing. Enter. Now I want to go ahead and put some other things in here. I'll say echo. This is an executable file using the -x bit. Let me make it easy. Let's give executable file. We're not talking about, okay? And then I'm going to put another thing in here, echo uh, this file was created on. Now I'm going to use a variable called d for date, right? Echo uptime equals to dollar uptime. Okay. Um, okay. Sorry about that. Then we have basically have to, hold on a second. Well, I made a mistake here. So we have to go, let me close this out and clean the file up. Okay. So cat vi and the output .txt. Let me clean that up for a minute. Let me clean up this. Let me clean this up. What I wanted to put in there was uptime. Okay. Remove that. Okay. So we're gonna do cat EOF into the output dot txt, and I'm going to enter there bin bash. I'm going to put in there echo, and I'll just do one thing here. Date equals to $date. Echo uptime equals to $uptime. Okay. And then we go EOF. And now we can Chmod plus X on output dot txt. And if I run this command as an executable file, it's gonna give you some date and uptime. Okay, it's supposed to input. We're not doing bash scripting, but I'm showing you if you want to execute the file, or simply you can put things in the file. So this is one method to do so, all right, which is using the double arrows. Don't worry about bash scripting. We're not doing bash scripting now, but I'm just giving you an introduction to how in bash scripting we're going to be working.
Sir, a quick question.
Yes, sir.
Why are we using cat command for writing in? Why don't we use win to
This is
write
the
in this
no, this is the syntax.
set? Okay.
ये syntax है इसका ये.
Hmm.
ये syntax है इसका. This is the syntax for you to, if you want to use a redirect quickly. Maybe you have 3 inputs. You have a large file, and you just want to input 2 or 3 lines in the large file. You don't want to open it and go and make the changes.
Uh-huh. Okay.
So, but because this one you can only put one item at a time. One item. ये दोनों one item के लिए. This one you can put multiple items in the file. Right? You can by using, this is the syntax of it. That's all it is. Okay. So you keep with the syntax, and that's how it works well for you. You find something else online which is better than that, let me know. But this is the most popular syntax I've used. We're going to remove that. That's a mistake. Let's get that out of the way. So don't, with the dev null and all that, we're going to do some exercises. But today, we really want to jump into something more. Okay. So let's get going. We know how to remove a file, how to remove a directory. We're going to do a few examples of that. We talked about SE Linux. We're going to cover SE Linux next week. And you're going to see this. Somebody had asked me, what is the meaning of this slide? This slide of SE Linux Practice Lab that we are talking about, right? And using this is one, there are 2 questions on the Red Hat exam in which you're supposed to use the cmanage login. But we are going to talk about SE Linux next week. So the idea was for you to understand why do I bring this slide here? So hold on to that question. Why I'm not explaining, why do I even bring the slide here? Why do I have this slide here? Why? Okay. So to answer that question, why did I even waste my time if I'm going to teach this next week? Right? Why did I say install this and run this command? Look at how SE is managing your system. If you look at the stat command, in the stat command, you have all of this information. So why even talk about it here? Right? Somebody had asked me the question, what is this slide for? Okay. This is to show you, let me go down. Hold on a minute. My exit is not working. 1 second, 1 second. Let me see how to get rid of this. 1 second. All right. Stop the thing. I'm trying to okay. Let me do this. Let me share my screen again. Okay. I'll share my screen one more time with all of you. Right. Right. See, where do I have it? Right here. I'm going to teach a fundamental concept, but I'm going to show it to you now. You see, um, S, SE Linux is a watchdog. It is sitting on your entire system watching it. It's watching every file. It is watching every file that you have in the system. How do you know it is watching your file? Let us do ls. Sorry, let's do this. This dot, 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 this dot. This is SE Linux. If you don't see SE Linux, this dot will not be there. This means that the watchdog, kutta, watchdog, right? I mean, it doesn't mean that way. In Urdu, it's a little bit bad the way you describe it. But the watchdog is a very popular word used by security systems, a watchdog system, automatically keeping an eye on your stuff, right? If you are not paying attention, if you are not very much familiar with the Linux system, you have a system by design that is watching your system. Your entire system is being watched by SE Linux. And how do I know that? That is because you can see the dot at the end. When we remove this watchdog, this dot is supposed to go away. Okay. So right now, all your files, folders, everything is being watched. And that dot in the end is telling you that you have the watchdog watching this file. Okay. SE Linux is looking at this. Okay. So we are going to come down to it. We're going to come down to it. We have a lot of work to do today. We have a lot of area to cover, but we're going to cover it very nicely and easy. So basically, we are going to cover the watchdog. This is the watchdog, SE Linux. This is the watchdog. Okay. So now you know where this SE Linux is going to be, is where SE Linux is sitting in your system. Everywhere you see the dot in your file, SE Linux is sitting there. No matter what file you create, you'll have a dog. The watchdogs Linux, this tells you Linux is enforced. Linux is watching you. Okay. It is watching this entire file. It's watching, I mean, sorry, this is a directory. Watching the directory. It's going to watch this file. The watchdog is here. SE Linux is being enforced. SE Linux is your default system, is in a security enhanced. SE, security enhanced. If you're sleeping, the watchdog is doing the job. It gives you the peace of mind that my system is safe. A hacker cannot come inside and destroy a Linux machine. That's why Linux is so popular. Very hard to hack a Linux machine. Very hard. It's not even almost near impossible to hack Linux machines because of the SE Linux watchdog. It is watching the port. It is watching who's coming in. It's watching the login. It's watching how you change your password. It is watching everything you're doing in the system, right? It is the watchdog system in that Linux has put for you. All right. So I hope you understand that. Uh, so when you come down here to the second slide, okay, when I look at Linux security, so Linux security, SE Linux is working the three parts. Today, ladies and gentlemen, we are going to cover the 25%. The 25% of the Red Hat exam is sitting over here. Okay, that is what we're going to cover. Next week, we're going to look at this. The week after that, we're going to look at that. They are there, but the most important one you're tested on is DAC, discretionary access control. Discretion, what is the meaning of discretionary? That means within the system, you can change some file permissions and directory permissions, right? That's why it brings us to user and file permissions. Now, user and file permissions, as you know, is all about the owner, group, and other, right? You can see in front of your screen, that the most important thing is going to be your ownership, the group, and others. How these three can work together, right? Then we are going to, this is a mistake here because AI, this is ACL, okay? ACL, right? Let's keep it up now. Answer, let me know what time is it. Whoever is in the US, let me know what time it is. We need to take a break. Um, also for 10 minutes for everybody. So we are going to learn all this these Linux file permissions. Okay. So let's close that out. Let's close that out. Let's move on. Okay. There are 6 things that you need to know in order to master the exam. Okay. 6 things you need to know. The extended attributes, we will not cover them today, but we'll cover the most important ones for the red hat. You can see the red hat is over here. And I bring this up to all of you that when we use the touch command to create a file and then ls-l, you're going to be able to see an output, right? File permissions make up about 30% of the Red Hat exam. Easy to master, easy to become an expert in Linux. Okay, it's going to be 1 week of hard work, and imagine that you have mastered 25% of Linux. Imagine what a milestone that is for you, right? It's a big milestone, right? A lot of people don't understand this file permissions. They think they understand it. Some people even pass the exam with knowing how to use the file permissions. But there is a process of building this hamburger. Okay, so so file type, these are basically only 2 file types. You know the file type you see here. I'm using the word file type. I'm going to go over this again. So you have a file type. If you look at the end, you have a file type. You either see a dash or you see a D, right? You either see a dash, right? You're going to either see a dash or you're going to see a D. Dash is for the file, D is for the directory. Okay. Then you're going to see the permissions. Owner permission. John is the owner. He created this file. So what are the permissions that John has? These are John's permissions. Okay. Unix is a group. What does the group have permissions? What permissions? You are Isra Kausar is here, for example. We have Isaac. Isaac. Let's say Isaac is the one who is creating a file in the system. We are going to talk about that. What is going on? There is some permissions. Okay. These are not magic. Okay. It's not like out of the sky, something is falling down and some permissions have been given to you. There is a structure. There is a structure in place. There is a method in place. Okay. There is no such thing as magic. There's a structure. Everything is structured in Linux. Okay. So we need to understand that when anybody creates a file, this is 25% of the exams, ladies and gentlemen. You master this, you're going to master Linux. If you understand this 25%, then 90% of Linux is a piece of cake. Easy peasy, right? Easy peasy, because we want to use Linux to build applications. So you can't do that unless you know this. This is the nitty gritty. This is the most difficult part of Linux, the most challenging part of Linux. Beyond this, everything we are going to learn is so easy. Run the command, get the output. Run the command, get the output. No mind, you have to waste no time. Just run the command, you will get the output. 90% of the Linux is going to be that way. 80% will be that way, except for bash scripting. Okay. So other than that, you are mastering Linux today. So I'm keep saying that to you so that you stay focused. Okay. Don't lose focus. Okay. Don't say I don't understand. If you don't understand, I'm going to open the forum for question and answer. And let me look at the time right now. It's 11:27. It is 11:27 right now. Okay. 3 more minutes. We're going to stop. We'll take a good 15-minute break and then we'll come back. 15 minute. In the 15-minute, if you have questions, good. If you want to chill out, chill out. Understand this, ladies and gentlemen. Understand this clearly. When you create a file, when you touch the touch command, when you say touch and you put a file name, okay, file. Let's say you create a file. What happens? This is what happens to that file. Something happens. The first thing Linux is going to do, it's going to determine if this is a file or is this a directory. So if you said mkdir, right, mkdir, then you will get a D over here. If you say touch, you're not going to see the D. You're going to see the dash, the minus sign, okay, the hyphen, okay, many different ways. So I see the hyphen. This is the file type. It's a file type. That's what it is. What type of a file is this? Okay, it has some permissions. From here to here, there is one set of permission. From here to here, there's another set of permissions. From here to here, we have another set of permissions. So we have 3 permissions. 1, 2, 3. 3 permissions. 1, 2, and this is 3, which is others. Okay. We don't see the 3 here. There is no 3. Okay. There's no 3 showing here. Nothing. The 3 is only here. This is the last part of the of your display, your output. 1 is the owner. 1 is the owner. 2 is the group. 2 is the group. You want to see this? What is the owner? You can find the owner's name. You want to know what is the group permission? You can find the group. That's how you know that. Because 1 is the permission, 1 is the name. Okay, because you need to know what name of that group is, right? So we're not going to look at all of this yet. Don't waste your time and energy. There's a whole slide on this. Okay, then we have the file name. Okay, we don't worry about the date. We're not worried about the size. We're not talking about that right now. We're only talking about the permissions and the owner permission and the group permission. All right. So we are very clear to move forward. All right. Now, and if you read this document I've sent to you, file types are basically 2, directory and files. You can see I've summarized this over here for you. What everything I'm saying to you, I had to take the time to make sure that for the rest of your life, when you're doing Linux, anything I'm teaching you, you don't have to watch the video. You can read the slide. What I'm teaching you is in front of you. It'll save you a lot of time. Okay. So you have the directory, right? And the files. That's the type. We got the type. Now permissions. You have 3 types of permissions. Read, write, execute. Okay. And then the read, write, execute permissions are applied to 3 categories, right? The owner, the group, and others, right? So you have the owner, right? And then you have a group. Maybe you have a group. And then you have maybe others. So there is a group as G. This is the owner. That is O. And U, user. And others is O. So it's a UGO. Okay. That's it. The user, the group, the owner. All the game is going to be played within this 3. Right? Clear this drawing, clear that, and let's go down. Let's see. So I'm going to just end at this slide. We'll take a break. So when you look at that statement, it is, you can see what the D stands for. You can see the user permissions. You can see everything clearly. In one slide, I made this very clear to you, what I just said to you. Okay. So if you are just paying attention to the slides, you don't need to watch the video and spend 4 hours to reread this, and I need to catch up. I have removed all that problem for you. If you just open the slide and you want to follow what we are doing, great. Okay, I'm showing you what it is. This is the normal permissions. So these file permissions, we are going to talk about them after the break. All right. Thank you very much. We appreciate what you're doing, and we will come back in 15 minutes. If you have any questions, go ahead and ask me some questions. In the meantime, I'm going to end this recording. Yeah. if I can. Let me pause the recording, resume the recording. 11:48 without wasting any time. So we have talked about the structure, right, of the permissions. So today we are going to focus on this slide, the permissions, the owner, group, and permissions. How these permissions of read, write, execute, how do they work? How can we master these boxes? We have a total of uh, we have box number 1, which is the type, right, which is this box over here. Then we have this box to master, which is box number 2, right? We have to master this box number 3, and we have this box number 4. If we understand how these boxes are working, if we can look inside this box and see how this works with the 3 and 4, how does 3 work with 2 and 4? How does 4 work with 1 and 2 and 3? And if this is a directory or a file, okay? So this is 25% of the Red Hat exam. That's what they want you to know. You should know how the read, write, execute works with the owners, with the group, and with others. Okay, so this is U, right? This is G, right? And this is O. So this is UGO, UGO. So as long as you know that UGO, user group owner, that's all file permission is about. But it isn't as simple as it looks like. That is why they test you on the exam on this. It looks very simple and straightforward, and it is. But once you understand how they're working, then you will be very comfortable in using them. So the first thing that happens in the system, right, is that the Linux has a predefined value, okay, of 022, okay, and this predefined value, you can find it in the file called etc login.defs. We talked about it. We're going to keep talking about it today until you memorize this file, right? So there is a file in the system, okay, called cat etc dot login dot define definition defs. And when you look at this file, right, you're going to see a number of things. And I'm going to show it to you in the beginning today so that you are very clear what is going on, right? So this is the beginning of the file. In the beginning of the file, if you come down, right, if you come down a little bit on this file, there are some values that are put in there. Number 1, here you got umask 022, umask, okay? So what is happening with umask 22, right? So remember this, that when we started the computer, right? When we start the machine, when you start your machine, it goes through a boot process, right? And then it goes to an initialization process. It gives you the system D, right? System D comes on, which is PID 1. Okay, now you got PID 1, a lot of things start to happen. There is some pre-initialization that takes place, and then there is initialization that takes place. We have talked about this extensively, right? So during that process, and when system D comes on and it presents you your bash, it gives you your shell, your bash shell, right? This is your shell. This is like your notepad, your notebook, right? The good old days when there were no computers, you had a notebook. Today we call this notebook the bash shell, okay? If you're in the Windows, it is called the PowerShell, right? So now that you have got your screen in front of you, this system D, in its process of initialization, goes into a file called etc login def. It comes to this file. It comes inside here. It finds this value, okay? and it continues and it finds this value and it applies that value. And then it continues and it looks at, oh, let's look at the maximum number of days, what and what not. Okay, it continuously goes through the file. It goes through this file and it says, okay, we are going to create a mask. We are going to mask we are going to take the hard-coded value. Hard-coded value. Remember, I just said that to you, that you have your machine starts and your kernel, which is a C++ program running inside the machine with the operating system. It is now taking you to PID1, right? And it's taking you through a process. In that process, it hits this etc dot login dot def process. It is going through this process, right? When you boot something, you will see all these processes pop up. And it goes through this file. What does it find in this file? It finds that there's a thing called umask equal to 022. It finds that there is a thing called home mode 0700. Okay. Now there is a hard-coded value in the C++ program. Program, you have a code. You have a code inside this. Okay. That is what we are calling it a hard-coded. Hard-coded, meaning this operating system already has a value. There are two values here, hard-coded. One value that is hard-coded for files is equal to 666. There's another hard code valued in the system for the directory called is the numerical value is 777. Okay? Hard coded. Is everybody clear? Clear hai bhai sab log? Everybody
Yes.
clear?
Yes, so far, sir. Everything good.
Very good. Hard coded. What is hard coded? This is in the Linux kernel program. You cannot change it. Nobody can change it. This is already in the system. Understand this. You are born, you have a heart. You cannot do anything. It's already there. You have been born with a heart. You have been born with a liver. You have your parts. It's hard coded. Your DNA that is coming in you, it is hard coded. So this is hard coded. This is the DNA from the kernel. And that value is 666777. Now, when you do the process and you come to PID1 and you go past that, and when this whole hard code goes through this file, it sees 022. So what does it do? It takes 666 minuses from this 022. That is the mask. That is the umask value that you're seeing over here. You're minusing. Okay, minus. It takes the hard-coded value of 777 minus 022. This is the umask value. And it gives you what? This gives you 6, 4, 4. And this gives you 7, 5, 5. These are called permissions. This is the mother of permissions. This is where permissions are allocated. This is called permissions. Ijazatnama. This is your permit. Now the permissions have been assigned. System is starting from the kernel, goes through a boot process. After it reaches the system D, right? It goes through another bunch of stuff, initialization, pre-initialization, bunch of things are happening here. There. One of the actions is that the system goes into the etc login dev file. And as you can see, ladies and gentlemen, this file is open in front of you. The process is coming here. It is checking this umask, this value. And it says, you know what? The hard-coded value is 666. The configuration file, where are the configuration files for Linux? Under the etc folder. This is where you will find all your air configuration file. If I ever tell you configuration, right? If I tell you configuration, it is under this folder, etc. So you can see that this is etc. See over here. Under etc, I have a login.defs. Under the login.defs, it takes the 7666 minus 022, giving me 644. It takes 777 minus 022 equal to 755. What is 644? What is 755? Tell me, ladies and gentlemen, what are those? Permissions. What are those? Open your mic and tell me, please. I want to hear that word. Permissions.
Permissions.
Thank you. Yeah, I want to know if you understand what permissions means. You cannot go into the Red Hat exam and you're talking about permission and you're thinking, oh, Chamod, LAS, JS, permissions. These are permissions. So easy in Linux. If you understand this, now your life, you have removed 80% of the burden of understanding the next part I'm going to teach you. 80% of this course has become easy for you if you understand what I just showed to you. Okay? All these tables, plus, minus, are very hard to explain. But now you should know that when you boot up, it goes through a process. It comes to system D. It goes and finds the file, configuration file. In that configuration file, we have login.defs. In the login.defs, we have a permission called 022 called umask value. Okay? Umask. I'm forgetting what U stands for, but I think it's some word. You can Google and somebody can find out and tell me what the U stands for. I don't remember that right now. Is universal, unilateral, something like that. Mask value. So it is a user. Thank you. So user mask. Thank you, sir. Now that you have got the permissions, everybody is loud and clear. Ji, sir. Bole. Khan Sahab, please add.
User permission.
User permission. Thank you, sir. So this is the user permission now. And you can change this value. Do I need to change the value? No. Does the Red Hat exam ask you to change the value? No. But why? Because it's a standard in Linux. Unless you have some very special company you're working for that wants to change this, nobody changes this. Nobody changes this unless you are in a special group. So the company does very specialty work where they don't need this value. Most people leave the
default value.
Default. Thank you, sir. Default value. Okay. And it is a very good value. So you don't need to go to bed thinking, should I change it? Are we going to change it? No, we're going to leave it as it is. Now, there is another thing, ladies and gentlemen. There's another thing that you can see here. Where is my eraser? Let me see. Where is my eraser and stuff? Annotation. Okay, good. Let me remove all of this. Now, let me remove this. We have another one here, ladies and gentlemen. What is that? What is that? Okay. There is another special permission created in this system, right? Remember, we went into the boot process, and remember that we went into the PID1. Okay, I'm going to keep telling you this. Remember that the kernel has the hard-coded value, right? That is the kernel that has the 6. We are done with that part. The 666, 777, okay? That's the hard-coded value. It comes in here into the etc def, login defs, and it finds out, number one, what does it find out? It finds out the UMask, okay? And it gives the default user permissions using the 022. Takes the value, minuses this. Takes the value, and then it gives you for the file, for the directory. You have your 644 permissions, and you have 755 permissions. Done. Then the program goes down, and it finds this home mode, where you have home mode. Home mode, it doesn't say minus anything. It just says apply. Just apply 0700. Just apply 0700. What is the home mode? What is the home mode? This is the home mode, ladies and gentlemen, that when a user, whether the user is coming as a root, right? If the user is coming as a regular user, as a person is coming as a regular user, let's say the person logging into this machine, into this virtual machine, happens to be dev1. Dev1 is the user, not root. Dev1 is the user. So when it turns it on, the machine goes PID, it checks and realizes, because remember that this person has a UID, which is not equal to 0. It is not 0. So the program checks and sees, hey, check the UID. Let's check his identification first. Is this a 0 or is a regular user? If it is a regular user, come down to this home, and the directory that is created, home dev 1, will have the permission 0700 on it. That is the permission that you're going to have on over here, on this dev. Meaning, we are going to see that. Let me show you. Let me show you what this means. Okay. Before I take away this diagram, I just want to show you that what we are trying to do is, we are okay with this. Everybody understand the user permissions. That will be applied on the file. That will be applied on the directories. Now there is a directory for a user, a normal user called dev, or John, or Ifra, Momin, whoever, Sahid, anybody who's sitting here. Okay. Now it applies a 0700 permission on that. What does that mean? So let us clear that, and let's go to the end of the line. Okay. There is an audit command. There's a command for auditing. Auditing. If you guys want to know anything on what is on, what permissions are there, memorize this command. Name I-L. Okay. So let us look at CD home. Okay. We have some users, right? I'm root. I'm seeing all these users. Now, if I want to see, you can see that these users have certain permissions. These permissions are 700. These are 700. But unfortunately, ladies and gentlemen, if I show you and teach you using this method, your mind will not be able to see what we are trying to see. You want to see this as a system admin. You want a big picture in your mind. The only way you can have a big picture in your mind is you have to use a command called name I-L, and now you're going to apply that on home and on dev1. Hit enter. What does it show you? That the folder, this root folder has this permission. This is a directory. So you're starting out, this is a tree. This is a tree. This command is showing you this is one of the top-notch commands to use all the time. Okay. You are going to have from this tree command, this is like a tree. So you are the user. Okay. What is the first gate? You're going to come to this one. Okay. You're entering the house. You're entering into this file system. You have a file system over here. Okay. And you are trying to enter in. So let's check. We are going to have a check here. Let's check you out. What are the permissions? This is a directory, D. What is the permission on this file? It is R, X, R, X, R, X. This is the permission on this file. Okay. So that means the user, the group, and other. This is, ladies and gentlemen, this guy here is dev 3. And dev 3 is trying to go through this file folder and go to dev 1. Right? This is dev 3. So can dev 3 pass through this one? Yes. Dev 3 can pass through this one. But let me clear this up. There's a mistake here. So the first thing he's going to do, right? The first thing he's going to do is he's going to go through you're going through the gate. So you have cleared the first gate. Why did I clear the first gate? Tell me, why did I clear? Am I a user? Yes, I am. But I'm trying to get to dev. I'm trying to get to dev 2. So I am actually other. I am others. I'm coming from outside. I'm curious what Isaac is doing. We are all working in the same team. I'm very curious. The manager calls Isaac. Isaac is laughing on the phone. He say, yeah. So I'm curious. I'm jealous. All right. I'm like, man, I'm curious. Let's find out what Isaac is doing. Let's find out what's going on in his folder. Let's get the beef. I mean, he's a nice guy, but let me find out what was he talking to the manager on the phone. So I am dev 3. I'm others. So I decided let's go and check out what's going on in his home, right? In his home. Okay. Now in the home, what do we have here? Home. So first step, I'm okay. I cleared the first step. Why? Because I am others. This is my column. I am over here. I'm others. Okay. I am others. I am other. I am other. I am others. I'm still able to go in as pass the first gate. I'm okay. Can I pass through the second gate? Yes, I can pass through the second gate. Yes, I can see home. I can see the home folder also. Dev 3 can see home. Why? Because Dev 3, the home folder here has permissions. What are the permissions? Telling you right here. D, R, W, X. Then you have R, X. And then you have R, X. So I have the permissions. I am others. I am others. I still have permission to come inside here. What about dev? One folder. This is where we are having a problem. This is where you stop. This is the stop sign. Stop. You cannot go past this gate. Why? Anybody can tell me why?
But there is no permission for the dev3 to go there because there is no
There,
read, write, or execute there.
there is no permissions to others.
There is only permission for the owner only,
Very good,
not
sir,
the
Asim.
second group.
Thank you, Hassan Asim. There is only permission for the, if you look at this dev, there is only permission to the owner. And in Linux, we use a symbol for owner called U. There is only you can read in and write and execute. Execute is something we need to learn. What execute what? Can he cat? Can he ls? So this is, there is no execution. This is nothing there. Nothing. Stop. He has been stopped. This is where the stop is happening. So right here, that's it. This guy, dev3, cannot see what is inside Isaac's folder. Isaac is dev2. I am dev3. And I'm curious because his manager was laughing with him, and a human being like me and most of us, we think, oh, what is the manager laughing with him about? So I'm curious and I want to go and see what Isaac is working on. Now, Linux has not allowed me to go there. And who is responsible for this stop? The 0700. This is coming from the etc login.defs. That is where this permission on the home is applied. This is where that 0700 permission is applied. Okay, this is a very special permission. Okay, and it is in Linux. If you remove that permission, okay, then you got a problem. Most people don't remove it. You don't remove the 0700 permission out of it. If you make this permission 755, then you can allow everybody who's coming through this. If you put a 755, 755 is what? Let's look at, let me explain that. If I go ahead and put, if I go ahead and remove the 0700 permission. So currently we got a permission on this gate is 700. Okay. 700 is equal to, we are going to learn this. 700 is equal to 4 for read plus 2 for write plus 1 for execute. So this is equal to 7. So that's why you have 7. And here everything is 0. If you make this 0 plus 0 plus 0, this is 0, 0. So owner has full rights, group has 0 rights, and others have 0 permissions. If I want to change these permissions, only root can change this permission. Remember, we are sitting in root. We are the super admin, right? Now, ladies and gentlemen, if I apply a command to change or modify using the Chamu, we are going to learn about this coming up. If I want to change, I want to apply a change to this permissions, and I make these permissions 755, right? On the home and on dev 2, I will open the gate. I will open this gate completely. Do I want to do that? No, sir. I do not want to do that. Okay? Because, so then how do we collaborate? How can dev allow people to collaborate with his folders? Now we understand the basic file structure from etc dev login devs. Now you all understand this. I've said it a million times. etc login.dev. You got the umask, which is all these other permissions you have got on the file system. Here you have 755. This permission here on home is 755, right? On the directory, this is coming from umask, right? Okay. And on the home directory, right? On the home directory, you're also seeing a different kind of permission on it. Okay. You're seeing a permission of which is 4 plus 1, which is 555. Permission is coming here. Okay, that's a permission coming here. So don't worry about the root, the topmost. Don't worry about that, because that permission is not what you're ever going to be asked about or worry about. It's already there, given. Also, there's a file that modifies that, which is also there. But our goal is to look at how we are going down. Okay. So now let us clear all of this. Let us clear all of this. Okay. So let me show you something. All right. I am right now root, and I'm going to enter here as I'm going to enter here as dev 3. I'm entering here as dev 3. Okay. And if I do the name I-L command on home of dev 1 or dev 2, that is the problem. So let me do cd. Let me do cd. Can I cd into root? Yes. Can I cd into home? Yes. Can I list everything in here? Yes. Can I cd into dev 2 folder? Permission denied. Why, Asim, do you think permission is denied? Permission is denied because the permission here is 755. I'm others. I don't have any permission to come inside dev2's folder. I cannot see anything, right? So this is how permissions are set. When the Unix system is given, Unix system is handed over to you in your bash shell, this is the base. This is what is already set. These are the defaults. This is what you need to know in your mind, what you're working with. Okay. So this is what is the default. Okay. Now, if dev goes and checks his files, right, and he creates a file, he touch and creates a file called cs main.py, and he looks at the file permissions on main.py, right? What are the permissions here? 644, right? What are the permissions? 644. These are defaults. How do you get the 644? Let's jump into that. Okay, let's jump into that. So the first thing is you are looking at hard-coded 644. Let me go here. So your default, ladies and gentlemen, is coming. Your default is coming from the kernel for the files 666 minus that 644, and your defaults are going to look like that. Same thing for the directory 777 minus 022 755, and any directories here you're going to make in your shell are going to have these permissions. This is how the system is handed over to you as a user or a system admin. Linux, after it has done the PID1, it has gone through etc def login.defs. It is handing over to you a shell that has those fundamental default permissions. These are the default permissions. That's the word default, right? And these are the default permissions. So 644 is, how do we get to these numbers? Let's look at that. Okay. So we have read, which is 4, write is 2, execute is 1, and in the symbolic mode, that is called UGO, right? And you have certain operators that we are going to use that you can actually apply. For example, in this example, if you wanted to change the permissions, the default permissions to a different permission, because when you're working in the Linux environment, and it's sometimes required that you change the permissions and make those changes, so that maybe you're trying to launch an application. When we do patching, we're going to show you how all these permissions are going to work. When we do the bash script, you will see you have to change the permissions. Okay. So two mode, you can type 600 or you can type a chmod u equal to read write, which is 6, comma, group and others equal, nothing after that. So that's equal to 0, right? There is no value here. And you apply that to the main.py. So there are two ways to run this, and we will look at both of these ways. Let's keep on going, right? So why is my system okay? Okay, what's going on? Right. So chmod command is changing the file permissions, right? The chmod command is used to change the permissions of a file or directory. And there are two ways to use the command, right? Which is the absolute mode or the symbolic mode. Now, you guys don't need to worry your brain too much. You can choose the way you like. You don't need to use the symbolic mode. Oh, so we are taking a class in Linux, so I need to memorize. Do not worry about all of that. I like the absolute mode, 766, 4766. 7 is 4 plus 2 plus 1. I like that. Some people don't like that. Some people's mind works symbolically. So they have a symbolic mode. And we will exercise on both of them. So don't panic and worry about, oh, are we supposed to? No. You're not supposed to memorize anything. Just understand one mode and practice the other mode if you just want to learn more about it. But to me, I like the absolute mode. Sometimes when we do bash scripting, we're going to use the absolute mode. So absolute or this, the Red Hat exam doesn't care which mode you use. As long as you know, you understand read, write, execute equals to 4 plus 2 plus 1, you got it. You're done. You don't need to worry about. Okay. So let's keep on going. Let's keep on going. Now, if you notice in this slide, right, I have put 4 in front of this. This is a special bit, right? If you look at this class that we are teaching, we said here in the beginning, right here, we have covered UMask. Everybody by now should under UMask. You should have mastered it today, okay? And we have put some, okay, so UMask, let me go back, okay? We have covered the file permissions. We are on file permissions now, 2. Okay, the second thing we are covering today, right now, is chmod. How do you change ch or modify permissions? Read, what are the permissions? Read, write, execute, access. So we are on line number 3. There are 6 things we want to learn to pass the Red Hat exam. Out of the 6 things, ladies and gentlemen, you are now almost at 50% of the 25% you need to learn. Imagine how well you will do on this exam and how well you will master this subject. So we have been talking about L1 support, L2 support. People have been asking me, when is that starting? Well, until we finish the file permissions, nobody can be really called an L1 support. You must know how live file permissions work. That is a mandatory requirement for you to have 25% of Linux in your brain. That's 25% of core Linux that you're learning today. Important. Everything is running on permissions, right? Part of this 25 to 30% will be SE Linux, which we'll do next week. Tomorrow's class will be in Urdu. Okay, so now we have talked about the chmod command. There's a symbolical and symbolic and sorry, let's go forward. So we are comparing this command URW, what do you get? 755. These are for your information. I don't need to go over these slides. These are just for your information. Compare what 700 will look like if you were typing 700. If it was 644 and you didn't want to use 644, you could use U equal to RW. If you want to do 600, you could just use that one. So these are the most common permissions you will see on the planet Earth. On the planet Earth. Okay, if you're working in the moon, I don't know what permissions they have there. But on Earth, these are the most common permissions, right? Not 200 permissions, 700 is common, 600 and 644 are the most common. People go from 644 to 600 or they go to 644. So under the category of 600, these are the most popular ones. 777 is the ultimate. If nothing is working and you want to test something out, 777, meaning open up everything, open all the gates, open all the permissions. If the problem is too much, this is only used for testing purposes. A root is testing some accesses for people. You use 777 for testing. 777 gives the what is his name? Gives the root. 777 is all the permissions. You can see that. All the read write permissions are there.
Unconfined.
Unconfined. Unconfined. Very good. Nothing stopping them. 100%. Do whatever you want. So, which is a dangerous permission. You don't want to try that, right? That is why UMask is putting 755 and 644. So between these, for 755, these are the two popular for 700, and these are the two popular for 600, commonly used at your jobs. So if your manager asks me, oh, you're having a problem, quickly go and make it 6. If you come to a permission and realize that I was working a job 2 years ago with Arista, and we were trying to move some files, and I'm going to bring that lab for you guys also. So we're trying to take some images, and we're trying to move them. And I'm like, what can I unload this? And it was in the temp directory. So when I looked at the permission, it was 600. So I'm others. Okay, I'm others. And the owner has put this condition. But I was able to go and chmod it and make it 644. So I took it back to 644, right? Where I was able to read or execute. Meaning I was able to take that file, execute some operation on it. I could move it, I could copy it, I could do some operation on that file I could do. Okay. This is how the Linux world is working. Very easy if you understand the defaults. Now, so absolute mode, I have an example for that. How you can use the absolute mode, chmod 600. You can change it. I'll show you something real quick. When you're changing a file permission on, let's say, dev3 has some files, main.py. Current file permission is 644. I want to change that file permission. Chmod, okay, 600 on main.py. If I do, now you can say I went from 644 to 600. Here's the permission. Okay, so this is how we change permissions. Very straightforward, very easy. Let's see the time. 12:30. We started at so we can go 5 more minutes, so we can close this topic out. So you have the absolute mode, you have the symbolic mode. If you use the symbolic mode, 600 would be applied this way. I don't like the symbolic mode too much. Some people love it. Okay, but you will see that there are some places we do need it for simple operations. So absolute mode, symbolic mode. I like this one. Easy. I can do the math in my head. That is 4 plus 2, 6. So, okay, that's my permission. Read and write. 0, 0, 0. Everything, I'm good to go. One shot, I got the answer that I need. All right. Now, I can also run the stat command, stat on statistics on Pi. And it'll tell you, here's your main file. It has a permission of 600. What does it look like? The ID of the user is dev3. There's no group assigned to it. The only group assigned is dev3. We are going to talk about this. We're going to talk about this file until you master this file. Okay, right. But let's go to the next thing. Right. Let's go to the next thing. Any questions at this time? From anybody? No questions. Symbolic mode, very easy. Changing the file permissions, right? UMask, we talked about this. You don't need to worry about this diagram. Don't even need to worry about all this. what I've put here. In fact, I may even remove this diagram and put the one I showed you today. This is an old diagram and it is a little bit complicated. We don't really need this. Okay. We have talked about this diagram even last week. So we went to the UMask and one, and we have also changed the home directory of 0700. You can all see this 0700. So today we have covered two parts of this file. Okay. You understand this, you have mastered this, you have mastered this. Okay. And when we come to password aging controls, the change command, okay, we're not going to do it today. I'm not going to teach that today because that's going into this file. That's also a Red Hat exam question. They test these things. These are the things that are testing you in the exam. Okay. How can you change the aging? I don't want to talk about this, and I'll tell you why I don't want to talk about this. Because in order to get into all of this aging and controls, you need a very good fundamental understanding of what the heck is this aging controls. Okay. Sounds straightforward, but there is something that we need to understand about how to use this. Just like you now understand UMask. I want anybody who's sitting here to tell me, I don't understand this. Anybody who today does not understand what we are doing, please raise your hand, open your mic, tell me I'm confused. I don't know what you're doing. Tell me that we have a problem here. We have a situation where we don't get it what you're doing. I want somebody to tell me that.
I have a quick question.
Yes.
So you talked about UMask. Is UMask temporary or like does it change the permission for like permanent, or is it just like until the terminal session lasts?
The UMass is a very good question. When you log in, when your machine starts, that
Mm-hmm.
UMask value is only is applied according to the def, according to what you have in the UMask value over here, until that session lasts, that value is applied, right? And that's a
Oh,
good question
okay.
because when you sometimes change groups, tokens, especially with passwords,
Mm-hmm.
password is based on tokens, something called a token. When you have a
Mm-hmm.
token, tokens don't get updated. So when your session is running, if you change certain tokens, they don't get changed. You don't see the change. You have to exit and come back. You can't just refresh and start all over again. So when the session starts, right, and if you decide to change this value while the session is running, it will only apply to those files that you're using within that session. And then the ones you have already created, let's say you created files with 644, okay? And was in your session one. Session one, you logged in session one. Now, while you're working, you decided to go to the UMask. You went into this file, okay? And you decided to change this to 600, okay? Now you start creating more files. Now, the ones that have already been created with 644 are not going to change. They're going to stay as it is. It's only the new files that you're going to create will take those values. Make sense?
Uh, no, not really.
Okay. So you understand that when the system starts, right? What happens next? Tell me.
Default
Where is
permissions.
where are the default permissions? In the
In
kernel.
the kernel. Okay.
Yeah, they are in the kernel. They are hard coded. What are those
Mm-hmm.
values? Six,
Either 644 or yeah,
666. No, sir.
666. Okay, sorry. 666.
777. They are
Mm.
666. Don't worry. Don't worry. If you're wrong or right, I don't think that because you're asking a question, oh, I'm getting offended. I want you to learn it. Okay.
Mm.
After the 100 days, you decide to go and take the exam and you flunk the exam. I'm the one to be blamed. So I have to make sure you understand this. You are running too fast. You need to slow down. That's your number one problem. You are wanting to get to the end result and this. Relax. Take a deep breath. We'll get through this. Kernel has 666, has 777. Are we clear?
Okay.
Then where does it go? Which file does it go to? This file in front of you. Read the file for me.
Login.devs.
At C,
Or
at C,
at C login.devs. Yeah.
right. Why do I say at
Mm.
C? Because at C is where all the
Configuration.
configuration. Thank
Yeah.
you. Thank you,
Yep.
sir. Then we go to the login.devs. Now you're
Mm-hmm.
inside the file. It says minus everything out of this, right?
Okay.
What is the UMask? It is saying
You.
apply the permissions using this minus this value from the hard coded value, right?
Okay.
So what does the output come out of this box? 644
Uh, 644
and
and
755.
755. Yeah.
Now you have this permissions available and applying on your bash shell,
Mm-hmm.
right? Now you are typing here everything, you are using the touch command,
Mm-hmm.
mkdir. What values are being applied? 644, 755.
Mm-hmm.
Now
Okay.
within the system, if you decide to use the chmod command, whatever you are going to change the value to will stay that value for that file. When the system starts up again, it's not going to go here. If you have changed, if you use the chmod command, right, and
Mm-hmm.
you have applied a value of 600 on a file, okay, and
Okay.
you decide to exit the system. When you come
Mm-hmm.
back in the system again, it's going to take the same process. It's going to take the hard-coded value, minus 022, 644. It is only permissions, okay? But this file has already been modified. It has inherited 600. You have modified it to 600. Coming back in the
Mm.
system will not change it to 644 again.
Okay. So Chmod is kind of like permanent forever. It keeps that permission.
That is
But
right. That
UMask
is right.
is only for the session.
That is right. It's for only for
Okay.
very good one. Very good. That I knew that is where your question was coming. I know exactly what your concern is because when the session starts, there are default permissions. Apply them as you like. But when
Mm-hmm.
you're inside the session and you decide to modify the permissions, then those modified permissions will stay. And when you start the machine again, it will still give you the default for the new files that you're going to create.
Hmm.
I hope that answers your question. If not, go ahead and ask again. Don't worry. There is no good
No,
or
thank you
bad
so much.
question in Linux. I want
Yeah.
you to be able to pass that exam. I want you to be able to explain this to somebody else. And also, you need to be able to explain it to yourself. If you cannot
Mm-hmm.
explain it to yourself, then you have to ask that question. So, see, by
Mm-hmm.
asking this question, it has benefited everybody. Go ahead. Go ahead. If you have any more good questions, I'm a very good question. MashaAllah. Any
Sorry,
other questions?
one more
Eh,
question just came to my mind. So let's say I changed using CSmod, I changed the permission of a folder, and then I create a new file inside that folder. Would it take the permission using the CSmod, or would it take the default permission?
Okay. So again, very good question. And these are all coming up because we are going to talk about changing these file permissions using. But let's go ahead. Let me clear this for you. Let me clear this for you. Let me try and see if I can get out of the screen. It takes a while to get out. Hold on. Okay. And the show. Okay. Fine. Now let me come in here as a developer 3, right? Okay. And if I look at inside my folders, I have a file called main. I want to go ahead and create another file folder called project. Okay. Um, um, dev3. Okay. What? Okay. Oh yeah, that's because mkdir. I'm using the absolute path. I'm not doing this. I'm creating a project folder here. Okay. So we do that. Now we have the project file. Okay. So if I look at the PWD, the path is coming this way, right? If I do CD project, okay, CD project, and sorry, and I do PWD, Now that is my path, right? If I look at the permission, the first thing you need to do is look at all the permissions. Name, I, -L, and let's take a look at all the permissions that are being applied. That's your first job to do, okay? Before you answer the question to yourself, because when you join any environment, like the question you've asked, the only way you can answer that question, again, only way I can answer that question is to examine what's on the ground. I can't tell you, oh, if you go into the folder and and you create the file, yes, the permission will be. Believe me, the 100 people who are sitting here, I don't know how many are sitting here, but will not have a clue what we are talking about. So we need some evidence. And using the evidence, we need to understand what you want to achieve. So now you ask the question, what is it that you want to achieve? Run this name I-L command on any file, any path, and ask yourself the question, what is it that you want to do? So now you tell me, what do you want to do? Before you ask that question, what is your question? Now everybody can understand your question. Why? Because we have a clear understanding of the paths, how the permissions are being applied. What are you trying to do? Where are you trying to go? What exactly do you want to do? Now you tell me, what is your question? Now you look at the forensics in front of you. You are the system admin. You can ask me this question. I could have answered to you, yes, when you go into the directory of this, is it for others or for the group? Or my brother, there are 1 million ways to look at the problem. The only way you can be certain about how the problem is going to be solved is you're going to run the name I-L command. When you run that command, it's going to tell you gate number 1, that's the permission. Gate number 2, that's the permission. Gate number 3, that's the permission. Gate number 4, that's the permission. Who is trying to come inside? Who you don't want to come inside? Is this for collaboration? Is it dev 1 is trying to come inside? Others are coming inside. A group needs to access this. And so we have to ask 3 questions. In your question, you have a very good question. There are 3 things. Who needs to access this? Who? Who needs to access this? Well, you are the user. You're not in, the question is not about you. So there's only 2 people left in the equation. It's the group, right? Can you allow some people in a group that can access this? Or do you want to apply others? Others mean maybe you got 5 people, you're working in different projects and they need to see something, the others. Where is the group here? The group on this file, my brother, is you have dev 3. This is the group. Do you think that the group called Linux team can access this? No, because this is saying this permission is applying to the user and to this group. If a person with a group called Linux team comes inside, this permission is going to say, stop, they're not allowed. Or if they are allowed, what is the permission on the group here? The permission on the group is they can read, they cannot write, but they can definitely execute. Okay, so we are going to get into that. This is the topic that becomes very sensitive. This is where you need to grasp. So this is what we are teaching. We're going to take a break. We're going to come back, and the remaining slides are going to answer that question you're asking. There's no straight answer to this until you understand who is it that's trying to access this. Okay, can I go and create a folder? Did you say, can I create a folder? You are the user. Of course, you can create a folder. Can dev create a folder in this? Can he? No, dev 2 cannot. Why? Tell me why dev 2 cannot create it.
Because he doesn't have the permissions,
Right.
the right permission.
Exactly.
He's in other.
Right. Right. So that is how you're going to examine permissions. Our goal here is to learn how to have that forensic expertise to examine who can come in and who do we want to come in, make it available. The whole science of permissions is on this question you asked. How do we examine the problem And then when we can, once we know by running this command, we know 100%, right? Then we can answer the question. Okay, what is your question? Can I put a file? Yes, you are I. I is the user. This is already user's file and folder. So I doesn't have a problem. I has no issue. Can I do it? Yes. Can a group create a file in here? No, because write permission is equal to 0. Can others create a file inside your folder? No,
No.
because the write permissions are 0. That means you have R-X on the group and you have R minus X on who? On others.
Others.
So the read permission is there. Yeah, he can read it. Can they come in the folder and read your material? Yes. Right now, ladies and gentlemen, let me ask you this question. Can this person, can dev to read the project? The permission on the project is yes, he can read. Right? This is dev 3. Dev 1 wants to read dev. He can read. But if we try that, let's try it. You'll see that it's going to tell you something interesting. And what is it going to tell you? What is it going to tell you? And that's where you have to understand the 0700 permission very carefully. Okay, let's clear that. Now, let's clear this. So let's bring in user number 2. This is going to be dev 2. Dev 2. Aaja bachcha maidan mein. The buddy is in the field now. Dev 2. Dev 2 says, hey, let me check out Dev 1's file permissions. Home, Dev 3, project. So Dev 3 is going to do what? What does it tell Dev 3?
Permission denied.
Denied. Why is permission denied? Where is the problem? Where is the gatekeeper? Right here. He, even though the project folder itself has permissions on it, but the gatekeeper, this dev 3 is the showstopper. You're not going to go ahead past dev 3 because dev 3's home folder has this permission that says no way. Until you remove this gate out of the way, there is no way dev 3 can put anything. Now, does the file folder have, does others have read permission?
Read.
Yes.
Yep.
Now let's try. Let's see if we can read that file. How do you have to read it? LS. Okay. No. Let's try ls-ld for the directory. Even L will work, but we want to look at the directory, which is home, which is for dev 3, dev 2. Sorry, we are in dev 2. So we want to look at dev 3, right? And then we are going to look at project. Permission denied. It is telling him permission denied. But we are only trying to do, we are just trying to read. And this guy says, hey, there is read permission. So why is he not able to read? Because in order to do a traversal, there's a concept called in Linux called traversal concept. Okay, what is that concept of traversal? Traversal means. Okay, let's put it out there. Let's show you. 1 second. That means that the user, right, the user dev 3 can move and see the home, can pass the home and get past. Here it gets stopped. We know that. If he can make it past this and he can get to the project, it will be able to see every content inside here. Agreed?
Yep.
This is where the problem is right now. So the person can, this is the traversal problem. It's a very unique problem that most people, when they learn Linux, they finish the class, and we did not even teach this last time, okay? Until I ran into this problem multiple times, and I realized, wait a minute, we missed something. We missed something very important, okay? Because there is the file permission, which is saying the project has the file permission of read W for others. So why can others get this permission denied? They denied is because they can't get past this permission first. This is a 700 permission here. No way, Jose, you're going past my doors. Once you pass through these doors, yes, you can see this. Let us do that. Let us try that, and then we'll take a break after this. So let dev2 wants to, who will modify this for dev2? Root. Root will modify this. Root will say, okay, let me chmod. It is 700. Let me make it 755. Okay. I can make it 755. On what?
Yeah.
On home, on
Dev3.
dev3. Now that it has changed it, let's try this guy again. Let's try this guy again. You see the permission removed?
Yeah. Now it has read and execute for broken.
Permission denied has been removed.
Yeah.
Now this guy can execute.
Yeah.
Can we go ls-ll?
Yep.
Can we? Yes.
Yep.
How very nice, no? Very fun.
Yeah.
Very interesting. And if you understand this bit of Linux, you are on the top of your game. Most Linux admins who come right out of the cohort don't get this. And we also apologize to our last cohort. We didn't go through this. I should have gone through this. You guys are uniquely learning this actually in this cohort, because this is it teaches you the concept of the login files, and it also teaches you how to traverse through the files. So whenever you get a permission denied, what command do you run? You run the name I-L command, and name I-L command is going to give you all your conditions in the path. So your path is very clear. Am I getting stuck here? Yes, no. Here it says no. Am I getting stuck in home? No. Am I getting stuck in dev3? No. Am I getting stuck in project? No. Can I see what's in project? Yes. Who can? Whatever the permissions are there, we have cleared everything. We have removed the roadblock. Make sense? Right. So with that being said, inshallah, we'll take a break and we'll allow everybody another 15 minutes. And thank you, Asir, right, Saeed?
Acha.
बहुत अच्छा सवाल है. Excellent question. I'm glad you asked. It has helped a lot of people to understand. And please ask, keep asking. You're actually part of our L1, L2, L3 also. So I'm glad you're asking this question. And right. Very good. Let's try this. Right. So we have looked at all of this, right? And you can practice the UMask, right? We have already checked this out. There's not much here to do. That was just a UMask practice. 1 second, guys. 1 second. Resume. Yeah. So this slide is nothing. Okay. I might modify this, but it's really not something that we've already covered all of this. How to create a file and a directory, and you can see the permissions on those file and directories. That's all we're doing here. We looked at the etc login defs. Okay. We're going to talk eventually about PAM. This is FYI. We're going to keep moving from this one. So in summary, when it comes to file permissions, Linux has a policy that applies on all the files. This is what I've been talking about. It enforces the UMask based on login dev. Let's understand this clearly. I've explained that. Your hard code comes in as 666777, goes through the log and defs, minus the value, and your output is going to be 644 and 755. Very clear. So carefully read this and understand this. Okay. So file permissions, as we have seen, they are discretionary. This refers to the security model in which the owner of a resource, file, or directory has control over its access permissions. Okay, that's we're talking about that. So what commands are affected by permissions? Clearly, when we say read, write, and execute, okay? When we say read, write, and execute, so read is when you're running the ls command, the cat command, the touch command, the less command, the more, grab, tail, head. The user will be able to read a file, right? If you use the touch command also to create a file. Wait a minute, why is touch? No. This is a mistake. This is a mistake. No, sir. It cannot be the touch command here. This is read, right? This is going to be over here. Sorry, make that change. There's some typo error there. So, ls, cat, less, more, grab, tail, and head. The user will be able to read a file, which means, so you can look at what happens, but I'm going to make your life very easy. There are only two things that you need to remember. Okay. You can read through all of this material, but the main thing is the read permissions are affecting the ls command, and the execute permissions affect the cat command. Okay. The ls command is asking, give me the list of file names. Okay. When you type ls, give me the name of the files inside the folder. So if we remove the read permission, right, ls will fail with the permission denied. Okay. Sorry about that. If you remove the read permission, okay, if you remove the read permission from this, and let's say you have an execute permission on this, or you had a write permission on this, and if you remove the read permission, I need to fix that, right? And then this should be this should be the opposite of that. I got too much in my going on, so that's why I was made a little mistake over there. So we need to understand this again one more time. Okay, let's understand this one more time. Fundamental concept, right? So when you have the ls command, it requires read. So if you run the ls command and you get a permission denied, that means you have reading rights are being denied. That's what it means. And if the cat command is not working, okay, that means your execute is not working, right? We'll go in and look at this. This is something that cannot be memorized. You just have to play around and see which command works, which doesn't work, and then you'll start to get a good feel. This is like when you're trying to learn a language, and somebody says, "Well, when you start using the language, you'll find certain things work a certain way, right?" Okay, so so we have talked about 644755. You can add a user and do 644655. Who am I? We have already done this. We have already checked changing permissions. We have taken all of this. So we've also talked about why permission denied error, right? We talked about that anyone can read, and we said about the auditing tool. We have talked about all of this, right? Permission denied. I just showed you how it is done. Now, let me go back here, right? And we said that, so how can we fix this problem? To allow dev2 to read the file, I've already walked you through this problem. And this is where you limit who can view your files. I just showed you that early on, how you can do that. Now, there is something called ACLs, access control lists. And we're going to see why we need ACL. What is the justification for ACL? That if I wanted to go ahead and set a ACL and modify it for a user called dev2 and just give him or her the access to dev1, that should be enough rather than opening up the doors for everybody else. So once dev1 applies either of those fixes, uh, dev1's command will work perfectly for dev2. Okay. So we're going to talk about this a little bit more. We're looking at the error, understanding 64755. Everybody should understand that really clearly how these are working. We'll do a bunch of exercises. Now there's another lab that I've set up here, right? And changing file permissions again from 644 to 600. We've already done this. And what does this mean? Owner is read write. Yep, so you should have a good understanding of the interpretation. I'm just doing it over and over again to help you understand. Okay. So I think I have this slide one more time. I already used the slide here. Let's see. Yeah, it came here. And this is here by mistake. All right. Okay, perfect. So the third part of the equation, right? The third part of the equation is this one. We have done umask, we have done file permissions. Now we are going to do file ownership. Change the file owner and group using user and group. Shown and group and change group. All right. This is on the Red Hat exam too. So how do you do that? Let's go down. Right? Let's go down. There we go. We are almost getting to number 3. So number 3 is the chown command, right? You can change the file ownership, right? You can change the ownership. If you want to change the ownership only, you can run this command. If you want to change the group only, you can run this command. If you want to change the group ownership and the group, you can run this command. Very simple. Let me show you. All right. Let me show you what this is going to be doing. This is the Open VPN. We're looking at the Open VPN. Everything is, we need to just completely remove the solution. So I'm going to close the Open VPN. Right. So we have ownership. How do I find out what groups dev3 belongs to? Just type the simple command. Dev3 belongs to the Linux team and the Git admin team and to dev3. Okay. We are going to understand this in detail. Okay. I want you to understand in these, the slides I'm going to show you later on are there. When you create a user, right? When you create a user, which we did on last Saturday, very easy part, create a user. Okay. And then you use the user add command. Okay. And let's say you created a user -u, you gave them an ID of 2000, and that user is let's see, let's find somebody. Isaac. Okay, Isaac, our friend Isaac over here, he is a user we are adding to the system. Now you can also just simply say user add Isaac. Okay, both of these commands will work fine. Only difference is this: Isaac, if you just do user add Isaac, what will happen is that it is going to go sequentially. Let's say that the available IDs, like your company, you got a spreadsheet, right? And in your spreadsheet, you have a column, okay? And Isaac has a company. Isaac, where are you located? Are you in US, Nigeria,
In
or Canada?
Texas.
Where, Isaac?
Texas.
Okay. So let's say, Isaac, this is your company. Okay. This is Isaac's company. Isaac is running an IT company, and I am hoping and I'm praying you'll have a very good, successful IT company working with us. So Isaac has a spreadsheet in his company, and here he has got users. Okay. So, and here he's got maybe the first name, the last name, and this person has just joined the company. And let's say that he has got John Michael joined the company. So in his spreadsheet, he puts John's first name, last name, maybe middle name, maybe he has other data, date of birth, license, this. Okay. So in his one, and let's say that this John is going to work for a department. Okay. Department is going to work for the Git team. Okay. Then Isaac has another one, which is Abraham Bartholomew. Okay. And he has over here maybe Usman Ali. Okay. So John is going to work for the Git group. Abraham is going to work for the Linux team. Okay. And Usman is going to be part of, let's say he's going to be part of the dev team. So now in your company, you have somebody who's managing your Git, you have people managing a Linux, and you have somebody who's your developer. So these are departments, and these departments are basically groups. This is the same thing as saying groups. Okay. These are your groups in your Linux system, right? So when we type the command groups, that is what we are trying to say, that you have a group. So dev3 is part of a group. Now let's look at where dev3 belongs. We say that dev3 is part of Linux team. This Linux team has a user called, okay. Now, this is dev3. Okay, whatever his first name and last name is. Okay. Now, he has a user ID. In the Linux system, when you start out, by default, if you don't assign an ID, Linux will assign an ID for you here. If you don't assign an ID, Linux will assign the ID 1001. Abraham 1002. Usman 1003. But now you applied a flag. You said -u, which means you're going to specify the ID number. ID number is 2000. So now if you apply over here, user add -u 2000, and it is dev3, then the value that is going to go over here is what? Tell me, Isaac.
It should be 2000.
Thank you. The value here will be 2000. And how do you force that value is by using this flag of -u. If you don't use the minus over here, that means it's going to keep on the next value would have been 1004, not 2000. And why 2000? Because you have different departments, right? Let's say that your department 2000 for dev3 is 1 second. Let's say that this is the department for that you have for developers. Anytime you hire a developers, they'll start at 2000. So if Dev3 was 2000, the next guy you have to give him 2001, 2002. Let's say you plan to expand your development team to 50 people. So you want to make sure that this range you have specified, you are making that range available in your department to handle 50 people, all the way to, let's say, 2051. So you have a whole range of people you're going to put under the development team. Maybe you're going to have 10 Linux users and maybe 2 Python users. This is Python. Okay. You have 5 Python guys or 2 Python guys. So you can define them with the flag U. Okay. So these are all groups. These are all groups. Okay. Everybody should understand groups. So when we run the command, okay, when we run the command over here, we are saying that we say groups dev3. That means that our user dev3 belongs to the Linux team, belongs to this team of Linux, and belongs to the to the Git team, right? He's a member of Git admin team, and he's also another group. He's part of another group called the Linux team. Okay, so he's part of that group, and then he's also part of Dev3. Dev3 is what? Remember that when you do user add and you check the ID, when you check the ID of Dev3, it's going to give you the ID, which is this one. This is the ID. This table is all the IDs here. All of these are IDs. Okay. It'll give the ID. Maybe the ID is 1003. Okay. It'll give you then it'll give you the group ID. Okay. And what is the group ID of Dev3? Dev3. When you start out, the primary group any user belongs to is the name, his own name. The secondary group that the person belongs to, the secondary group he belongs to, these are the secondary groups. Secondary group. Okay? Are we clear? Is everybody clear? Isaac, does it make sense to you? Any questions? Jason, Nwanko, do you understand? Anybody is not clear? All right.
We good.
Okay. Okay. Good. We need to know. If everybody's is understanding this. Okay. So yeah, this is user management. We have taught that last week, but I am reviewing it here with you so that you are clear, because user management and user permissions go hand in hand. So now we are going to see how this is the user. When you type in ID command in Linux and you put the name of the user here, for example, dev3, it's going to pull this is the data it's looking at. It's looking at the ID, the group, what group do you belong to, what group basically means what department are you working in. Are you working in the finance department? They maybe have a group called Fin, IN group, Fin group. Okay, you're not part of the Fin group. You're part of the Pi group, which is the Python group. Maybe you're part of the LX group, which is the Linux group. Companies don't just write big names like this. They just have some short mnemonic, like a mnemonic. Mnemonic means that a long word, maybe you can describe it with three letters. So if Git is easy, Git is 3 letters. Okay. Linux team, they will have maybe LXT, Linux team. The Python will be PY. Okay, team. Dev team will be developer, will be dev. SIT, UAT. Production will be prod. Right? All of these are mnemonics. Okay, short ways to remember the group. You don't have to say this is the part of the And so that's how we are looking at it. Okay. So clear all drawings. Okay. So now we are looking at the fact that dev3 is part of this group. Okay. What were we trying to teach? We were trying to change the ownership. Okay. So when we do the ID of dev3, ID of dev3, we realize is 1011 group. He's part of his primary group, but he's part of two secondary groups, right? He's part of two secondary groups, two secondary groups. Secondary groups are two. All right. There are two secondary groups, and he's part of a primary group, one primary group always, right? So when you create a user, their primary group is whatever the name of ID of the user, whatever the name of the user is. Okay, if it is dev3, then he's dev3 in the group. Okay, and the ID and here's see the group. He's part of the groups. So you can just type the command here groups. It'll tell you everything you need to know about this person's groups. Okay. So we said, okay, hit enter, control C. What is it? Where is it at? Oh, come on. Okay. ID dev3 groups. The word is right here. See, groups. I'm using the word over here. Groups. You can't forget this command now. Groups of dev3. And it is going to give me dev3 and all the primary group, the secondary group, the secondary groups. Okay. Primary is always one group only. That's the primary and those are the secondary. Very easy. You're done with user management. But now we have to do some more stuff. We are going to, how can we use this user and change his group, right? So we have a command called, let's look at what folders he has created in projects. He can create a file called, let's say, let's create a file called rsyslog.txt, touch a file called syslog.txt. He creates a touch a file called git errors.txt. I'll make it easy, log. So he created three files, ls, we can do ll, or we can do ls-l, same thing. So now we can see the permissions on the file. 644, that is 644. What is the dot? What is this dot, everybody? What is this dot? Anybody who can tell me what is the dot?
SC thingy? Security net?
Watchdog.
Yeah, SE Linux. SE Linux is enforced, is looking at everything. SE Linux, the watchdog, is watching this file. You have a hard link, you have the user dev3, and you have the group dev3. Where is the group? Dev3 group over here, dev3 group over here. Very clear? You say with the primary group. So what you see in this line, you will never see the secondary group. You're going to always see the primary group of dev. Okay. Now we have this is dev3. Let's look at dev2. Groups of dev2. Now dev2 is just part of this. We are going to go to group. If we look at the ID of dev2, dev2 only has one primary group, no secondary groups. So groups are only one group, which is the primary group. Now I do a group add. Let's look at all the groups in the system. What groups do we have already in our system? So I'm going to go and do tail. If I do tail only and I don't do n minus 5, if I don't do this, how many records will just the tail command show me? 10. 10 records. Let's look at the 10. I don't want to look at 10. I just want to look at 9. So if I just say tail etc password, okay. Oh.
Password spelling.
So now, sorry. So we don't need that. We need the group. Sorry, we're not going to password group. We want to see how many groups we have created in our company. So we have a Linux team group. We have a Git group. So these groups are already in the system because we know that these groups are already there in the system. How do we know that? Because everybody is in the same machine. We know that tail hyphen n hyphen 5 of etc group. Remember, the machine is the same. Dev3 is using the same machine. Dev2 is using the same machine, right? Dev2 is using the same machine. Dev3 is using. Let me bring 2 over here. Let me bring 2 over here and live 2 and 3. 2, 3, Linux. Everybody is using the same machine over here, right? So if I look at that, our etc groups. Tail hyphen n 5 etc group. Okay. So what he sees, dev2 is seeing the same thing that dev3 is seeing. Okay, everybody is seeing the same file. He's getting the same file, he's getting the same file. Both users are seeing the same file. Okay, so be very clear about that. So now we see that there's a Git admin group and Linux admin group. I would like to go ahead and add, okay, clear. I would like to add dev2, right? We see that we have groups for dev2 are how many? 1. So I'm going to go ahead and now group, what do you call this thing? Chamod hyphen G or hyphen AG. What is the difference between hyphen AG and just hyphen G? Hyphen A means append. Append. Right now we know that there's nothing to append. I can easily use hyphen G and I can add the Linux team to dev2. I'm saying change or modify the group, secondary group to Linux team. We are basically adding it to dev2. The mode.
Will you use modify group?
Is it not
No.
change
Group
group?
Yes.
Change mode is for change group is the right thing, I think.
Yeah, you're right. Change group. Okay. So let's go change group for Linux team dev2. Didn't work. So change group didn't work. So now we have the chown command, right? And in the chown command, I can take the user, I can take, well, why can we modify? So why should we not be able to modify hyphen AG Linux team O dev2? Okay. So now if we go into the root user and try that, even though it didn't stop us with the permissions, change. No, that's not chmod. We can use chmod, can we?
Sir, you can use modify group.
No, sir.
Mod
So now I've run all of these commands just to show you the effect so that you'll be clear in your mind what works, what doesn't work. Okay, so we can say user mod. Okay, user mod. Who are we modifying? Users, we are modifying the settings for the user. Okay, chmod is not going to work. Why? Because chmod is for file permissions.
Missions.
Right. So want to get this clear in your mind. I've intentionally run some commands to show you that, look, it's saying, look at the flag, look at this, but user mod hyphen G, okay, Linux team on dev2. Permission denied because only root can make those changes. Okay, so we have to go to root and the user mod, only he can go ahead and change. And if you are a root, now the root user has two options. If I don't want to see how many groups belong to dev3, meaning I don't want to do this step, dev3 as a root. I don't want to do that. Dev3, groups, dev2. Okay. I don't want to run all of these commands to let go, which I should. A good system admin will always check before you do what you're going to do next. But the most safest thing on the planet to do with user mod is to always add a capital G. A capital G is your safety. It means that I'll show you. Let's do it without A and with G. So capital G, okay. And I'm gonna first of all add the git admin. Okay, let's add git admin. Git admin to dev2. Okay, now groups dev2. Git admin. Let's run the command again with -G, and I will change it to Linux admin, Linux team. Okay, groups dev2. What happened to the git group? It got deleted because without using the A, if you don't do user mod -A, A equals to append. If you don't use this A, it's going to delete everything. Imagine you make that mistake and removing a developer from 7, 8 groups, and you just add him to a group with just the G. It's going to be a person can actually lose their job. The reason why is because that developer may be part of 8 or 9 groups. You remember, we can have maximum of 15 groups in Linux. One primary group, 15 secondary groups. A developer could be part of 9 or 10 teams he's supporting. And you went in there and ran the -G command and added him or her to git admin dev2. What happens? The Linux group, maybe the other groups that are sitting here, all the other groups, you're going to delete everything you got here for that person, and you're going to replace them with just one this. So the safest thing to do always is to use AG git admin dev2. So
सर
now we
कल मेरे से यही मिस्टेक हुई है.
okay, wonderful. आपने try किया था ये? Very good, very good. Somebody actually tried it and made that mistake. So by using AG, okay, on the Red Hat exam, I have gone through 2 interviews, 3 interviews in which they right off the bat asked me this question: how do I add a user to secondary groups? And if you said Chamod, you're wrong. If you said I used change group, is wrong, because how do user? So I'm modifying the settings of the user. This is a $1 million command. Most of every company uses this commands. This is their number 1 top command when it comes to adding people. So you can add more groups to that user. Remember, the primary group is dev2. Secondary groups, they can belong to multiple secondary groups. Okay. Now user -AG is you appending it. So now we didn't delete this. In fact, we appended this to the user Linux team. Let me clear the screen. We're at the bottom of the screen. Okay, are we clear? Is everybody clear what we're doing here? Right? When you have primary group, which is always just 1, and you have secondary groups, which can be up to 15 for a user. And if you do not use this flag, AG, you're going to remove all the groups that they belong to, and replace it with whatever group you're trying to give them. Let's say you're trying to give them Jenkins access. You're giving them to be part of Jenkins. This is a real group. Companies have Jenkins access. Developers have Jenkins access, right? So now you remove Jenkins access, and you removed all of them from the Linux team, A, B, C, D, and now that person is sitting in Nigeria, in India, in Canada. The team in India says, you know what? The user cannot access the files anymore because some admin came along and didn't do the due diligence of adding the flag A, and they just went and did -G. Okay, are we clear? Are we all very clear? All right.
Yes.
Now, so let's go to Chon. Okay, Chon, you can change the owner of a file. File. Not change the permissions on a user. We are talking about, when we say file, then we are talking Chon. If we are talking user, we are talking user mod. If we are talking file, we are talking mod, because you're changing permissions on a file. You're changing ownership on a file, or as a matter of fact, directory as well, right? We can do that to a file or a directory. But when you're talking about a user, then you're talking about user mod. So now it should be very clear how these commands are being used. Are we clear, everybody? Now you have mastered user management. Okay, very straightforward. One or two questions on user management, you guys will be very clear. Now we're learning today the 25%, and we are at that point that we're almost at 2 o'clock, right? So in 15 minutes, we'll go for another break. Control C, let's clear that, and let's pick up our presentation. Right, Shown ownership. So if I want to change, if I'm a user, okay, if I'm a user, when I create a LL, when I create any file, okay, in this, I think, Ibrahim, I'm using your machine. Ibrahim, are you here?
Yep, I'm here.
I think I'm using your machine.
Yeah, you are.
Okay,
It's
very
fine.
good. Yeah, I'll clean it up before I leave it today. Don't worry. You
No,
can,
it's
you can.
okay.
All right.
I don't mind.
All right, I appreciate
Exactly.
that. So I know your name is there. I can see it. I've been using this machine for showing it to everybody. So now, you know, what we have over here is now. So okay, good. So we have the primary group as dev1. Now, if I want to change the group on a file, we are going to change. Let's go into we are a root. Oh, sorry, we are root. Okay, so I want to become dev. Okay, who am I? Who am I? Root. Who am I? Dev2. Who am I? Dev3. I'm Dev3, I'm Dev2, and I am root. Okay? See that? I'm root. Who am I? That's how I know I won't make a mistake. Sometimes you're working in a file as a root and it says permission denied, permission denied. And the first thing, anytime you have a permission denied, type who am I? Because if you are root and thinking you're working in some other folder, you're going to have a lot of problems with permissions. Root has the global permissions to do a lot of things, right? So I'm in dev, and let's look at the files. I'm going to touch and create a main.py file, and I have that file over here. Permissions are there. SE Linux is watching. One hard link. user is dev, and the group is dev. Now I would like to change the ownership of this of this file. Okay, I can do the ownership of this dev2 is the owner, and the group is git admin, right, or Linux team on the file. So the operation is not permitted, right? Changing ownership of this main.py operation is not permitted, right? So he cannot change this file permission on this group, but root can. Root can change it. Okay, so let's go into the root. Who's going to try and change the ownership of dev to what is the dev2's Linux team main.py. Okay. Now, if we check it out, Control A. You can see that we have dev2 and that file name has been changed. 1 second, I have a call coming in. 1 second, please. Right. One of the things that groups dev2, which has kind of surprised me here, is that why was dev2 not allowed any? I want to look at this. Why, when dev2 is part of the Linux team group, right? When he's part of the Linux team group, if I removed him, if I just said user mod -g and I just said git admin to dev2, okay, and then I came as dev2 and I said, okay, I have a file, rm-rf. I want to remove all the file. So, okay, I have no file here. I'm going to create a file called main.py file, and I'm going to do ll on it. And so I am the user. And if I look at my groups for dev2, I'm not part of the Linux group. So if I wanted to do chown command on this one, right? If I want to do a chown and change the group ownership of main to Linux team, right? Main.py, then the operation is not permitted. Okay. Now, when I root decides to add me back in there, because remember, groups dev 2 is git admin only. So I'm going to go ahead. Root is going to say, okay, let's go ahead and modify, give ag Linux team to dev3. Okay, so dev3 has got that, and we can check the groups again, right? We can check the groups again. Now,
Have to give it to dev2, not 3.
oh, thank you. Thank you very much. Yeah, okay. Dev2. There we go. There we go. There we go. So Dev2 is now part of the Linux group. Now, when I try to do chown and main.py, it's saying it's not permitted. Okay. So there is a problem. And the problem is not that permission is not there. The issue is that the member of the session, when you change a group during session, a dev2 has to exit, right? And dev2 has to come back in again. Okay. And now if dev2 runs that command, Linux main pi, it should be able to add it on there. There you go. This is a very important thing that I wanted to show you. Okay. I hope you understood this. Number one.
1 minute, sir. I did not understand that you have to change the permission of Linux team to.
Right. Let me do it again for you. Let me show you. Let me show you here. So we have a group. Let's say we have a group. Let's remove all the group permissions from him, and let's just give him dev2. His secondary group is git admin. Okay. Now, what is the what groups? Okay, groups that dev2 belong to. Which group does he belong to? The secondary group, git admin.
Dev2 and git admin.
Right? Okay. Now let's just do rm-rf. Let's clear up everything here. Let me delete all the files and permissions or whatever. Okay. So let's say the dev has no files. Dev created a file called main.python files. You guys, when you're going to learn Python, this will be one of the things you'll learn about the main.py file. Okay. So touch main.py, Python. Okay. Let us look at this file. The permissions are 644. SE Linux is working fine. User is dev. Primary group is dev. Agreed?
Okay. Yes.
Okay. The permission is on the file. This is the file permission. Main.py file belongs to user dev and belongs to the group called dev2. Right? I would like to go ahead and use the chown command, because chown command has two parts. There is A and there is B. And then you have the main.py. Okay. What is A is equal to? A here is equal to user. And B here is equal to the group.
Okay.
So when you do colon, it is like a seesaw, right? There are two sides to this whole thing. So you have a colon here. This is the user, and on the other side is the group. Okay, but if you just write like this and you just give the group, you're going to change the permissions on your file main.py. You're changing the group. Here you're changing the user and the group. Here you're only changing only the group. And you can, if you just want to change the user, then you put it like this. And only the user will change it. Make sense?
Yes.
Yes, usloob. This is the way. You can define both of them, or you can define only one, or you can define only one. You can only define the user and it'll affect the main.py. Main.py. Only the group will change. What we are trying to do is we are trying to change only the group. So we are going to use this method. Okay. So we can even put the dev here. Doesn't matter. We want to put dev2. That's fine. It's not going to affect because we're not changing the user. The user is still staying the same. But if you don't need to use the user if you don't want to use it. But I can just give the group. Okay, so let's go ahead.
Sir, what I was thinking that if you take this file from dev, his group, and give to someone else, or just take it from them.
Very good. Iska, let me explain on this. A very good question. So we have we have okay, we have a file. Okay, number one. Now, look at the groups for dev. Dev is in which group? Dev2 is in which group? And look at groups. Dev3, which is in which group? Groups. Root. You can see root is in a group root. Okay, root has complete rights anywhere. Okay, so What we want to do is we want to do LL, do groups dev 3 and groups dev 2. Okay?
Okay.
We are at 2 o'clock. Very good. We need to push through here. Don't worry. Hang in there, guys. We'll make it through. So here dev 3 that you're seeing over here is part of 2 groups. Dev 2 over here is only part of the Git admin group.
Okay.
Now, when we said we want dev to change, you're right now you're dev, okay, and you want to change the ownership. You're dev.
Okay.
You are wanting to change the group, so you would just want to change the group, right?
Okay.
So group is Linux admin, but group dev's primary group is only one, and because he's not part of this group, he cannot assign this group to anybody. Main.py. All right. Invalid group. But Sean can assign to Git admin.
Sorry,
main.
is Linux team, not Linux admin.
Oh, sorry, Linux. Thank you. Okay.
Okay.
Sean Linux admin. Okay. Now he has assigned it. Even though where are we? Are we dev 2 or we dev 3? We are dev 2. And okay. Why do you think he was able to assign this? Tell me, even though he's not part of the Linux group. I'm going to show you something very. Let me explain this to you. You see, you have dev 1, they have dev 2, and you have dev 3. Okay. Initially, he's only part of Git admin group. As we're only looking at secondary group, Git admin. Okay. The first time we try to add and he is part of this, right? He's not part of the Linux admin group. There's a group called Linux team. Okay, Linux team. Dev 2 is not part of the Linux team. So when he runs the command shown, okay, and adds Linux team and main.py, okay, that was the first time we tried this operation. First time. It said he cannot do it. There was a problem. There was a problem over here. Permission was denied. Then we went into root. Okay, as a root user, we said, okay, let's go ahead and do user mod, and let's add him to the Linux team. That's what we did before. Agreed? Linux team main.py. These are first हमने ये किया था. Number 2, we did this, right? Then we came and tried it. It did not work again. We had to exit. Dev 2 had to exit and log back in, and then try the command. Try this first command again, and the problem went away. Now we decided to remove the group again from Linux team. Right, because now that he was added to the Linux team, he was able to assign Linux team to main.py.
Okay.
Right, because he was added as he was not part of this group, but he was added. So how come now he's able to do that? That's because Linux has a legacy memory. Linux has a memory on this. Because he has not done the exit yet, in the memory, it is still assuming that dev2 is associated with Linux team. It's like a cache memory type of thing. It is reading this, that dev is still part of the Linux team. That's why when we tried it now, it worked, even though he's not part of it. But you can see that if we try to remove him, if he exits again, the settings will change. But before we go that far, let us continue pushing through our material, because I'm going to come to that scenario. Okay, so understand that we can do chown. Chown command is used for doing the changing the ownership. I'll come to that problem. The problem I'm trying to describe to you, I'm going to come to that very soon. Okay, because a lot of people in Linux get confused. I am dev2. I'm not part of Linux team, yet I'm able to add a file. I'm able to take a file and assign the Linux team to it. I'm not part of the team, yet I'm assigning the team. That's not possible. Because that is the reason why, is because there is a legacy command running in the back. When once the user 2 exits and comes back in, they cannot do it. So we'll talk about it. Let's keep on going. So chown command, you can change the ownerships in root. That's why you see in this examples I'm using root. I'm not using users. Root is always easy. A lot of people teach using root because root is easy to do that. Group change the group. In place of chown, you can also use change group, and it'll also work fine. Okay, keep on going. So we are coming to a very important topic, which is pretty much almost two things left to teach today. Okay, and the problem I just talked about early on, we are coming to that problem very quickly, right? So ACL is something we need to understand. What time do we have? We have 12:18. We'll take a 10-minute break, and we will come back at 2:30. We'll take a 10-minute break. Welcome, everybody. I'm sorry I was on mute. My apology. Thank you for reminding me. I was speaking here without. So now we have covered almost 3/4, almost 75% of this subject, and you guys are doing really great. I commend this group to have the patience. Remember, this 4 hours you're giving today is not the 4 hours you're going to give every day, right? So most cohorts have 4 hours Saturday, 4 hours Sunday, right? We have been doing 2 hours, 3 hours. Now we're going to push hard. We want you to know the material. You need to know this. You have spent 6 weeks. So now to navigate, you're a bit more comfortable moving. Remember, ladies and gentlemen, very clearly, we have the SE Linux watchdog. The SE Linux watchdog is all over your Linux, the file system. Okay. Then within the watchdog system, the security, you have the root directory. Under the root directory, you have root, right? The home of root and the home of all other users. These are the users. This is the home and this is the users right over here. Okay. Now home, the root creates a user add command, user add dev1, user add dev2, user add dev3. The minute he uses this command, goes into this file, it goes into the login devs file, right? And it now defines the home mode of the user. Okay, the home mode. So this is the 700 permissions that you are seeing being applied to that folder. Okay, that is why dev cannot come over to dev2, dev3 cannot come over to dev1, dev1 cannot simply just go over and get past dev. So if dev2 wants to go and view this files under dev1, dev2 cannot go through here because there is 700 permission. Because of this login devs, you have a 700 permission. 700 permission does not allow this guy, when he wants to go into this folder here, it's going to get no permission unless you open the doors. Who opens the doors? If dev wants to open the doors, or root can open the doors. Okay. So then they can access this. Everything that's in the umask is 644.755. Any file in the system, whether it's under dev, whether it's under dev2, whether it's under dev3, whether it's under root, all the files are going to always have 644 for files, 755 for the directories. I hope you understand this map. Anybody who doesn't understand this map, please open your mic and ask me now. No questions? All good?
Clear.
Thank you very much. Now, this is just an exercise, right? Where I need to match this up. Let me see, user dev. We will create 3 users. Okay. User dev1 will create a file. Okay. Blah, 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 blah. Okay. Very good. We get a little problem over here. Okay. You have successfully changed your host name. Everybody, this is one of the things needed on the Red Hat exam. You must know how to change your host name, and you must know how to run this command without logging out and logging back in. These two, by now, you should know how to change your host name. You should play around every day with this command. Every day, you come in your machine, change the host name. Put your name over here. Put Linux over here. Put Git over here. Put RHCSA over here. Put Practice Lab over here. Every day, play with this command so you memorize it and how to check it. Okay, this is on the Red Hat exam. It's a good, nice, 10 points that you don't want to lose. Okay. So this is an easy peasy thing on the exam, and you should know how to use this command, right? Moving forward, we only have 30 slides. We can do them in 45 minutes. So I'm gonna, you can follow this lab if you want to, and you don't really have to right now. The lab is already going to come. Now, remember I said to you that when you touch a file, and you create a file called file share, right? And you create a directory. There is a dot. What is this dot? What we see at the end of the permissions? Answer. This is security enhanced Linux. Watchdog. Watching these files and directories. Remember always, permissions as per umask are 644.755. Permissions are always 644 and 755 up here 644, right? We have said that in this diagram. Permissions on files, but you have some exceptions like the one up here for security, because you have some security. So you have this home mode 700. When you create a user and his directory is created, the permission is 700, not 6404, not 755, but 700. So we need to be clear in our mind because it's a security issue, so that dev3 does not go into dev1's folder by mistake and start deleting things. If I give you permission in my folder, you give me permission in your folder, I can go and damage your file. Maybe you're working all night on a script. I go in there, check your script out. Oh, yeah, or Asim, you created such a nice script, and I make a mistake in your script, and I come out. Asim comes back in the morning. He has spent all night. His script is not working anymore. So there is a safeguard created by Linux, hard-coded safeguard. It says, go to this and put this permission. We are very clear. Now, we are very clear what the watchdog is doing. The watchdog is the SE Linux dot. We are going to talk about SE Linux next week, right? Now, this is a very nice example whereby I do echo relative path, and I'm going to redirect it into a file called output.txt. Note, we are using the relative path. I'm teaching you this again because in real life, this is where you're going to need it. You can also do the same thing using the absolute path. So you're echoing a phrase called relative path because you're sitting in the dev's own folder. This is the relative path, okay? And you can see the word relative path is there. Then your user dev1 creates a file under share using absolute path. You can create an absolute path. Echo absolute path /. Why did I show you these two examples? Why did I waste my time? Or did I not waste my time? Because, ladies and gentlemen, the tilde is there. This tilde, right? This tilde. Why this error? Why this error? Because tilde is equal to home and dev1. If you are already dev, when you say home, you put tilde, and you say dev1, that's a mistake because home and dev1. This is a very common mistake that people make. Okay, here what have I done here? I have done tilde dev1. Lot of people think that this means home. Yes, it does mean home. When you look at root, right, at Linux, tilde, yes, that is home of root. You can see here we have got this. We have got tilde. So what does tilde really mean? Tilde for a user does not mean /root. Tilde here equals this. Tilde here for a developer does not mean this. If you put this is equal to home dev1. This is all tilde. And then I have said tilde, and then on top of tilde, I put again dev1. So this statement is wrong. Lot of people keep making these mistakes and say, oh, why am I getting the no such file or directory? Why is this error? So I fixed the error over here. See here, I've said tilde, which means I'm saying home, dev, and then I'm saying, give me the path to the share. Then I'm saying, give me the file to the file. So this right here is tilde. Okay. This is tilde. This whole thing is tilde. So when you put tilde for a user and a tilde for root means this. Remember that. Remember that. All right. Remember that. That's all I'm trying to show you here. Okay. So user 2 in a separate window try to see dev1's file. We have already done this. We have already done this exercise. You don't have the permissions. We have already done this exercise, right? Where we want to go now is going into access controls. Okay. So we have said that this is because has standard permission of 700. Dev2 is stopped right there. The system never even gets the chance to check what are the permissions, right? We use this command and we're able to solve this. Look at what is going on, like the forensic, like you're checking it out. Okay, good. And now let us first check if ACLs are being applied. Okay. Remember, ladies and gentlemen, okay, when you look at LL, you have a dot. When ACLs are applied, you will see a plus sign. You are going to see a plus sign here. You are going to see a plus sign over here. Right over there, you're going to see a plus sign. You're going to see a dot and you're going to see a plus sign. Plus sign means ACLs are being applied. ACLs are being applied. Access control list. What is access control list? Everybody knows that when you go to work for a job, you have an access control list. You are in the office. You cannot go to the finance department. You cannot go into the data center. You are an IT professional, but you have no access to the servers. You're an IT professional, but you have no access to the Department of Accounts, right? So there is some access control that has to be given. So access control can be checked by using the command get, excuse me, let's check this file. Let's get the access control list for this file main.py. And it says the owner is dev2, the group is Linux admin, user has read-write permissions, group has this permissions, this is this permissions. Great. Now, if we apply set, we want to set a condition, set ACL, modify the user dev3, and dev3 is going to be given, let's say, read and write permissions or read, write, execute permissions on main.py. Now we can see something else. Remember that we had, these were the regular permissions. There were no ACLs. Now let us look at this. Look at the plus sign. Look at the plus sign. There was no plus sign before. Now you have the plus sign. Okay. You see the plus sign. The dot is SE Linux. SE Linux, the dot is hiding behind this, but it is there. Okay. Now we have plus sign here. So this one has got a special permission on it. And SE Linux is saying, okay, you've got some kind of special permission. We're going to change the color of this guy. We'll look at how you can change colors in Linux. Not important right now. Not even an important topic. But sometimes you go to work and somebody asks you just to test your capabilities. What does green mean? Somebody asked me one time. I said, I have no clue. I don't know. I never bothered myself to find out what green means. I'm just looking at this and this and this. I don't bother with the color of this main.py. But we are going to talk about colors too. Colors are important to us. Okay. So plus is telling me that I've got ACL. Where is the ACL? I've given permission, a special permission to dev3. So let's go to dev3. Dev3 is now going to check. He's going to check like the ls command. You have the get FACL command. Get. Remember that if I remove the F, get ACL. Okay. Now, the programmers have given this command, not just get ACL. Oh, that would be nice. They put an F in the middle. Okay. Okay. To get ACL. Right. I don't know what the logic is. I haven't studied what the logic is, and I don't really care. Right. No, you should not even worry about it. If you love to investigate how they developed and decided to put F in place of this and what it really means, why F, but get FACL. Okay. There you go. It's like the listing command. You want to see all the special access controls, you can use that. So let's go ahead and do get ACL on which folder? Home, dev. Now remember, we had the name I, -L, right? On home, dev, dev2, main.py. We don't have permission still. Meaning that if I tried to go to that file, even though I have access, let's see if we have access. Do we have any access? Even though my access, special access is available, right? On this dev2, right? Permission denied. It get fecal is, like I told you, it's like the ls command. So even then you cannot check what permissions have been given to you because you can't go past the gatekeeper. So unless we open that, unless we go ahead and open the permissions here, oh, I closed the root guard. Right? So I'm going to leave this over here. So first of all, let's go through our slide. We have literally 20 minutes to go to get through our stuff. So let me do the slideshow, then we'll stop and say. So we have said get FACL, and then you set the FACL, and you can see this in this slide. That's the first thing we need to understand. Can dev2 get past the home dev1 and access files and directories of dev1? Right? Can he or she do that? Right? If you do ls-l, okay, dev2 can do all of that of dev1, right? So can he cat this? Yes, system log. Can he go inside there? Sure enough. But remember that in this permission here, in this one, I have already, okay, between 4 and 5, what I'm missing here is that I have already given the 755 permission to dev1's folder. Okay, right? So if you open dev1, you'll be able to come through, and you can look at all of this stuff, right? So we'll keep on going. Can dev3 get past the access files and directories of dev1, right? ls-l. Dev3 is given is permission denied. Okay, all subsequent operations will fail. We'll try the ls-l, ls-ld, all those operations will fail because we have the same issue. So we're going to do a little exercise of this. I'm going to move on to show you something that I'll show you in the end. We need to get part. So ACL, I'll come back to it. I'll show you first. We need to get to special permissions. Why I'm avoiding this, and I think I need to maybe change a couple of slides here, but I think everything else is good. Everything else is good. To understand ACL, you need to know basically few things over here. What are they? You need to understand that M stands for modify. you will run that command. Okay. X is if you want to remove, clean something out. So if you're going to run this through the week, you're going to get your tasks during the week to do all of this. So in this class, I've given some tasks. If you guys have the notes, you can play around in the clarification session and through the exams. Questions you can come back and ask me. But the idea of that, we need to wrap up this last topic. If we can get past this one, this is very easy. So you have some special permissions, right? Where are these special permissions? Where do we find them in our system? We find them in our system over here. Over here. Let's find the final permission. Stat. Okay. Now, this special permission can be removed if we set that permission back with a plus X. Is plus X or minus X? Hold on a second. Hold on a second. Hold on a second. Let's go back up here and see. The flag is minus X. All the flags are minus X flags. Okay, good. Minus X, right? And the user is dev. Who did we give the permissions to? Yeah. No permission there. Dev3. Okay. Oh, did we remove it? Did we remove the permissions? Let's see. Let's see. Oh, this is dev2. Yeah, let's see. All right. Yeah. So here we go. I'm in the same thing. So let me look at the permissions. Access control to a specific user. I only wanted one person. This is the Red Hat exam. We have 2 questions on the Red Hat. We are going to tackle them through the week. Just understand the basic outline and the concept. Okay. Don't get too deep into it. Just look at it the way I'm presenting it to you. I would like to remove this access. How do I remove the access? I want to go ahead and set the ACL minus X. Okay. And to make your life easy, I have given you the syntax over here. Okay. So this is the syntax. Okay. If you want to remove everything, okay, you don't need any syntax. You can use this one, which is the best. In fact, on the exam, this is better to use than this one because minus X, user dev, to, and what permissions. Here you can just completely clean out all the access. If they ask you in the exam to clean all access, remove all access, or just remove access to dev2, then this is specific access removal. Remove specific user permissions and do not include the permissions. Okay, so what that means is we can remove the permissions from user, dev3, right? I don't need to specify the permissions. I just need to say main.py. Let's see what's going on.
You have to add user.
No. You have to use the user. It's the. Oh, hang on a second. Yeah, set AFACL. Are we missing a syntax? Minus, yeah, and the user. You're right, sir. Thank you. So you have to put, see how that made a mistake? Because if I didn't put that, and I'm on the exam, I'm going to have that problem, right? That's exactly what I was trying to simulate. Now, I can do it that way. If I had just used set FACL minus B main.py, this is so easy. Minus B doesn't give you minus X and U, okay? So what I simulated for you is to show you what I was just saying early on. This is a better command. The only way to learn is for me to just keep on making the mistakes. Because if you're on the exam and you made this, and you forgot the U, the syntax U, right? And somebody picked it up. They say, oh, you're missing a syntax U. Now on the exam, there's a lot of minus X, U, all on 1, 2, 3, 4 things. But minus B will remove everything. Will do the same job. Okay, good. There we have 17 minutes. Let's go. All right. So let's go to an exciting part and the final part of today's journey. We have some special IDs, right? That's what we talked about. What are those special IDs? Control C, clear, stat, main.py. Enter. There is a special ID. See the 0? This is file permissions. These are special bits that you set up, okay? And they also go in 4 to, sorry, the 421, yeah, 421, right? And it is setting up, if you can have, for example, you have 644, and you can have in front of it 4, 644, and you can have in front of it 2, 644, and you can have 1, 644, okay? So you can have 644, 644, and 644. This is the last part, the most important part. And out of this important part, the Red Hat exam is not going to test you on the 4, but Red Hat is going to test you on this one. 2. The 2 bit is the most important bit. So from the exam point of view, it is the most critical bit to learn. Okay. 4 is easy peasy. I'm going to show you right now. 1 is easy peasy. I'm going to show you right away. This will take us 2 minutes to learn, and this is going to take us 2 minutes to learn. The remaining heavy lift of the work we're going to do in the next 15 minutes, minus 2 minutes, minus 2 minutes. I need your 10 minutes to look at this, because that's where the Red Hat exam has the most questions. The most questions on user permissions, file permissions, special permissions come out of the 2 bit. Okay, now that you know what to look for, you cannot stress out about this, and you cannot stress out about this. Okay, we are worried about the 4. We are more worried about 2. This is the one that Red Hat is looking to test you on the most. This is a easy peasy. No worries, no concern. 2 minutes in and out, you're done. Right. So let's look at it now, guys. What I mean by it, we are done. Now let's go. We have done the ACLs. So we want to be able to see what's the impact if we put a 4, a 2, or a 1. What is going to happen, right? So now let's look at these special permissions. What do these special permissions do for us, right? So we are on a countdown, right? We're going to move quickly. Now, if you have the 4, right? If I set the 4 on this permissions, you'll see an alphabet is a special. This is a special permission, right? I just ran the stat command for you to give you an idea of what you're looking at. If you set this bit to 4, you will change something for the owner. If you set the bit only to 2, so in that diagram I showed you early on, ladies and gentlemen, if you set a 4, okay, you came here and you set 4, 6, 4, 4. Now this part you already know. So don't worry about this part. you know how these file permissions are working. You know, you are focused on the 4. 4 is something that's impacting only the user. 4 is impacting the user. And if you see the S, small s, or you see the large S, okay, we're going to talk about that. You'll see the S. What is the S replacing? In the background, you have DRW. You are replacing the execute bit with the S bit. Okay? You are replacing it in place of that. So if it's a small s, it means you're changing some kind of special permission, but this X is still valid. If this S is a big S like that, that means you don't have any execute permissions. But don't worry about all of that. We're going to clarify this mud as clear as mud as it is right now. Let's get through this. Now, SUID, right? SUID. It only works on files only. It has no effect on directories. Beautifly. You're good to go. It's only on. Now, if I ran the command, for example, where is password? The password is located in a bin, right? User bin password. I want to follow the notes so you can understand what we're doing here. So if I run ls-l on this, it shows you that there is a bit called S on the user side, right? What does this mean? It means, now what it doesn't mean? It means that if the user dev3, dev2, oh, this is dev3, password, okay? Now, user is trying to change the password, ABC. It's not allowing him to change. It says the password is the same as the old one. Okay, let's try a different one. London 1 at. Oh, it says, hey, this is a Red Hat exam. Notice carefully, guys. Dictionary. What are we doing here? All right, well, let's understand. So we're saying that there is a special permission called SUID, special user permission, meaning that dev3 can run the password command. And only we know there are certain commands that other users go. So what are those commands? Those commands, ladies and gentlemen, that a user can run is let's see. That's what it is. Okay. And you have all these commands, find. Your volume is not clear, sir. These are the only commands that users can run. User can run the mount command, the umount command, the su command. You know, we have been using su, cron tab command, password command, sudo command, change command, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of Linux can only run these 10 commands like who? Like root. Okay? These are the only 10 commands you can run. That's why you have a special bit on these. And you can check that special bit. ls-l, you can check user, bin, and mount, for example. See the special bit here? So this is called set the user ID. Now, you will never be asked in your life to change this. These are default settings, but it is here to explain to you that Linux has given some default settings where a normal user can change the password. Okay, a normal user can change the password. A normal user can type sudo and that command is going to work. A normal user can use the change command, right? Can use the mount command when we do the management. If normal user needs to schedule some jobs, cron tab jobs. So it has certain 10 commands, what you can call like the 10 commandments of user ID, basically. That's all you can run. And that's all you need to know. We are done with our 2 minutes. Let's move on. I think it's more than 2 minutes. So you have a special bit, or you saw the S, I've shown it to you. Set UID is not used on ls command because it is only reading. But password, su, sudo, gpassword, they all have a security risk, right? So we are applying this special bit to say that you have some access to it, right? So we did this. Where is password? You run the password. It said the S means that when a normal users run password, it runs with root privilege. So they can change their password, right? So password dev1, you are dev1, you change your password dev1. Only root can specify username. Okay, password, and it asked, we put in there London one at. That's what I was putting there. You didn't see me putting there, but London one at. The password fails the directory check. Okay. It said there was a bad password is a blocker. This message is coming from the PAM PW quality, right? So you have two files, ladies and gentlemen, two files that are critical, right? You have in modern Linux system, you have the login defs that only handles the aging expiration and the etc security pw quality.conf file that handles the password complexity, meaning that if you go into this file, right, etc security pw quality.conf, if you go inside that file, and I'm not going to open it, you can check it out. It's written here. If you go into this file, right, you're going to find out if you do not check this bit is set at 1. If you set it at 0, it's not going to do a dictionary check. So if you type a word London, and if this is equal to 1, it's going to look for London. There are like 40,000 words that in the dictionary that's going to look for, right? And if you want the length to be 3, right? Now root, we have been typing ABC. ABC is 3, 1, 2, 3. The length, minimum length, if you is in by default is 8. That's why it is failing in there. All right, I'll show you soon. Now clear all. Let's clear. Let's clear. Okay. Even though it says bad password, it hasn't logged dev out. It hasn't done anything strange. It is only checking for the dictionary, right? So fundamental concepts. Okay. I'm going to bypass these. I want you guys to read this stuff, right? If you're, for those who are in Urdu, you can grab this and put this in ChatGPT and it can explain to you, but simply I'm only explaining two things here. Logdef, the login.defs, the file dictates how long a password is valid, right? It has taken all that out, and now modern Linux is using the security pw quality.conf file. You're never going to encounter this, right? There's only one question on dictionary, only one question on the dictionary, and it's the final question on the Red Hat exam. It catches a lot of people by surprise. And the reason it catches them by surprise is because they have learned about password change, but when a user changes the password, they'd see, oh, the length, where do we change the length of the password? What is the dictionary they're talking about? So let's go forward, right? Let's go forward. So the password command hands you input over this blah, blah, blah. Bam looks up ABC or London 1 at. Looks inside here, right? But let's make your life easier. So if you do the listing of this file, user share cracklib, you'll find out there is something called dictionary password. This is an RHCSA exam. You have to do the DNF install words. Don't be confused. I'm only installing a dictionary here, right? There is a default dictionary called cracklib. It's like, you know how you crack a password? So this is like, okay, we have some of that dictionary information. If you need it, we'll give it to you. It's under dictionary PWD. But on the Red Hat exam, you have to run the DNF install these words. This is the dictionary. Okay, right. This is on the exam. So if you run that DNF install, you look at the word count, you have 478,000 words in that dictionary. It's only one question on the Red Hat exam. One question, guys, you need to prepare for. Okay, and so I've just given you some things to do here to enjoy. Okay, and this is the final bit. What time are we at? We are at 1 minute away. We needed a lot of time for this, but we're 1 minute away. The second bit is your SGI. Don't ignore the date. That date is an old date for last year. We used that slide from last year. So the next bit is the group bit. Okay. Now understand this very carefully. Before we leave tonight, we need to understand one thing. When you create when a user creates a file, the file gets the primary group. We have talked about this, right? Primary group of root is root. Primary group of dev is dev. The file inherits the root's primary group. The file inherited dev's primary group. We have seen that. I talked about it early on. This is the same concept. So when dev is creating a file, it gets dev. When root creates a file, it gets root. Right? We looked at it. File permissions are 644. Nothing else changes. We look at the ID of the dev. I've talked about this extensively early on. Right? I'm only repeating this in the slide. Now, let's go forward. So Linux without SGID, okay? Linux without SGID, we have talked about minus AG versus G. So let's go further down. We will realize, and this is a lab. We have to do this in a lab, which I've kind of demonstrated here, that first of all, you have to change Chmod 777. One way, you have two options. You can add, let me summarize this for you. Because it's very important to understand these slides when you're reading them. You remember that we ran we said home, dev 1, right? This file had what permissions? 700. This file had what permissions, right? No issues. 755. Okay. And anything you make in here, whether it's a file, if it's a file, it has 644. And if you create a directory, it has 755. Now, all of this belongs to, let's say, dev 2. Now comes along dev 1. Of course, this is the first showstopper. Or let's say dev 3, sorry, dev 3 is coming along. So if we add him to this group, we're talking about this group of dev is 3. He's been added to the group. Okay, and let us try to create a file in the share folder. And we have to go through all this trouble. add him first to the group, and let's see what else is going to happen. Again, the permission is denied. Okay, because Dev3 is still using an old login session. We're talking about the Linux only reads the user's group memberships at the exact moment they log in. Okay, so you have to always log out and log in if you're going to change any group membership. We'll go through this. Okay, now, ladies and gentlemen, we have two options. Option 2 would be to change the permissions. So what I'm showing you here in this example, right? All that talk I've done for the last hour, right? First is root. Okay, he's fine. But then dev is dev2. Okay, he has a file. And okay, but dev3 now needs to become Linux3, Linux team. He can access this. So this is a mess. You have created a bit called the 2-bit. The 2-bit does a very easy job when it comes to collaboration. Okay? Collaboration. I'm not spelling that right, but that's fine. Okay? Clear all. And that is where you come into this into this simple set GID. Okay? So if you solve that problem, if you did do chmod on any file, right? Any file, and you add a 2-bit on there, 2775, and you check it out, right? And that bit is over there. Remember, the permissions denied and everything. When we give that 2775 to the share directory, right? We are basically saying that we have a group that is being allowed. That group, it could be the Linux team group. We're going to work this problem through. This is the process of how it takes a look at it. Step 1 is dev2 the owner. The owner is root. Dev2 is not root. Move to the next step. Is dev2 a member of the group? The group ownership is Linux. Since dev2's primary group is dev2, they do not have Linux as a secondary group. They do not match the group. Step 3, everyone else. So without and with the GID. We're going to run some examples, and the final one is pretty straightforward and easy. This is usually applied on a temp folder. Everybody can put their files in the temp. They have the complete permissions like you see in the bottom here, but there's a T-bit, T-bit. You can see the T-bit. This T is over here. And T means you cannot delete anybody's files in the temporary folder. And that is all we have, ladies and gentlemen, the T-bit, right? And don't forget how to remove a directory and how to remove a file. And that's all we have for Linux today. Thank you for your time. We have gone 5 minutes overboard, but this slideshow and this coming week, we're going to put enough easy examples for you to solve this and run these labs. So you have a good understanding of SUID is pretty straightforward. GUID, set GID is the most important one. And the sticky bit is pretty straightforward. Sticky bit just means if any folder has sticky bit, that means everybody can come inside, they can view everybody's files, but they can write to their files, but they can delete the files. The T is for preventing you from deleting the files. You can't go inside and delete somebody's files. That's all I have for all of you today. If you have any questions, please